So good afternoon, all participants. So today is our last day, final day in our 6 days FDP. So now we have with us Bipin Gupta sir. So sir will take the session 11 on the topic portable and scalable CV, unlocking embedded diffusion with containers. So sir is the director of Unite Solution Moga Punjab, and sir have 30 years, more than 30 years industry experience. So please sir, you can start your session on this particular topic. Thank you, sir.
Thank you, Gautam. So let me share the screen. So straightway, I will be starting with the session because we have to cover a lot of things, and last 15 minutes I will keep for the question answers. And today's our topic is portable and scalable. Because whenever you are deploying the applications, it should be portable. And if you want hundreds of copy, 1000s of copy, that means it should be scalable. And in our case, there is first terms that we want to understand. That is, we have written that we want to unlock embedded vision with containers. So we have to understand what is containers. What was the earliest way of deploying application, and now how the industry have changed. Now 90% of the time when you are going to deploy any application, whether it is AI, DL, ML, or any type of application, behind the scene, you are going to use the containers. So we need to understand this is next generation technology. That means you are a master of certain technology, but how to deploy these type of things, then we have to use these containers. So we will be looking at what is containers. So let me go into a little bit background. So first of all, when we have to understand these containers, we have to understand one technology that is called Docker. So once we have understood the Docker, then we will be able to understand these containers. And then I will be, once we have understand how to use Docker, how to create container, then we will be taking 2 or 3 different applications. We will be deploying different application, and we will see the users. I always call this technology as magic technology. Now, what is magic about this? So let me go into a little bit back. Now, in my case, when I purchased this laptop, it is having around 16 GB RAM and 1.3, you can say, terabyte hard disk, and it has got i7 processor. Now, most of the time, although it is in, when I purchased this, Windows 10 was there. But most of the time, I use Linux platform. 95% of the time, I'm much more comfortable with Linux than the Windows. So one solution for me was that I was having the Windows and I could have installed the Linux dual booting. But these days in industry, nobody uses this dual booting. So what I do, in my case, I use the virtualization. Like in my case, I have installed the virtualization, VMware. You can install the VirtualBox or KVM or Hyper-V is there. Lot of choices are there. So in my case, Ubuntu is Linux. In the first day itself, I have given certain example in which I was using the Ubuntu. So in my case, when I was installing the Ubuntu, if you are going to carefully look, out of 16 GB, I have to allocate 8 GB to it because I was resources, and because I7 is equivalent to 8 processor, and some of the concept they required 2 processors, so I have given 2 processor to. Then hard disk was 100 GB. That means out of a 1.3 terabyte, I have to give this. Now let me go to the second system. In my case, second system, again, no need to open. It is showing that I'm giving 2 GB, 1 processor. Then I've got another operating system, 1 GB. Then another one operating system is there. If I'm going to calculate 8 GB, 2 GB, 10, 11, and 17 GB, I'm having total 16 GB. That means I cannot run all these 4 virtual machines. I can run 3 or 4. In my case, if you are going to carefully look, I have got more than 70 to 80 different virtual machines are there. So that means if you are using the virtualization technology with the resources, you can create 3 to 4 VMs. So I'm just explaining, then we will see where we have moved now. That means in my case, hardware that was 16 GB and that i7 and 1.3 terabyte, that was my hardware. And host operating system in my case was Windows. It could be Linux, it could be Mac. Then on that, I have installed certain virtualization software. In my case, it was VMware Workstation. And then I have created the virtual machines. Sometimes what happen in industry, they do not use this host operating system. So sometimes what they do on directly hardware, they install hypervisor. But again, participant, please mute your mics. Participant, mute your mic. Participant, please mute your mic. Thank you. That means whether we are using virtualization or hypervisor, we are going to get VMs. But the problem with the VMs is they are very resource intensive. So in my case, I'm giving the example 3 or 2. Even suppose I'm going to give each VM 1 GB RAM. Then how many VMs I can launch? Only 16. But I want 160 VMs. Or even I'm not satisfied with 160 VMs. What I want 1600 VMs with the same resources. Now these days, it is possible. We have got one technology which is available. The name of that technology is Docker. So we will see what will happen. So in my case, again, the hardware same. Host operating system, please, whenever you are using the Docker, it is preferable that you should host operating should be Linux, but now these days it is run on Windows system also, equally good Mac, but still we prefer Linux operating system. So in my case, hardware, Linux operating system, and then what we are going to do? We are going to install Docker. And sometimes if you have to install basic Docker utility, you have to just run one command, apt install docker.io, it will get installed. So I will be showing you the instruction, but in my case, I wanted to install Docker plus certain other components also. Now, please remember, when you are using the virtualization, what will you get? You will get the VMs. But when you are using the Docker, what you are going to get? You are going to get containers. Now, what is the difference? Let me show you. When we have to create the VMs, storage required is 4 to 60 GB. Like in my case, I have shown you that when I'm clicking on this 40 GB storage, here 6 GB storage, and here again 40 GB, and to this machine I have given even 100 GB storage. So this is the storage. And when we have to boot the virtual machine, it is going to take 20 to 40 seconds. And whenever we have to create the VMs, what we need certain ISO files, and the size of ISO file could be 700 to 6.5 GB. If you have to download Ubuntu desktop version, it is more approximately 5 GB. And if you are using Windows 2019 or 22 or 25, again the size will be more than you can say 4 GB. And if you are using a very old operating system, Windows XP, still it will be 700. That means if in my case I have got 60 to 70 different type of VMs are available, that means I have got lot of ISO available by using. And when you are installing the VMs, it takes 15 to 35 minutes. But in the case of Docker, first of all, we do not use the ISO. So in our case, we have to use the images. And you will be surprised to know the size of images is from 4 to 100 MB, 4 MB to 100 MB. That means 95% of the images that you are going to download, that will be having the size. And when I have to create the containers, how much time it is going to take? Hardly it is going to take seconds. Suppose I have to create 3 VMs. At least 20 minutes into 3, 60 minutes is going to take. But if I have to create 3 containers, it will hardly take, you can say 3 seconds. And sometimes it can take even less than 1 second. And how much time it will take to boot again. The moment we are going to click, container will create. And look at the storage. Here we were using that storage required 4 GB to 60 GB. And here we are specifying the storage it uses is hardly less than, it is less than 1 MB. So people call this as a lightweight virtualization, and other people, whatever we were using current, that is called heavy virtualization. So in our case, what we will be doing, we will be creating the containerization, containers, different application, like MNS that we are going to create container. For AI application, we are going to create the container. For different things, we are going to create the container. The benefit is it is much more efficient. Let me give you one real example. When I earlier started my career, I always, for 3 to 4 times in a year, I used to go to Bangalore. And I usually used to take train from Delhi to Bangalore, and that was Karnataka Express. And I still remember it used to take approximately 40 hours. That means approximately the time was 9 to 10 at New Delhi, and then it used to take 40 hours. But once, and although that flights were also available, but I was not that much comfortable with the flight. I was afraid of flying. But once for emergency, I have to go to some place, so I have to take that plane or flight to that place. Once I got to know that how much efficient, how much time it saves, then after that, I always use the Mathia. Whenever it is possible, I go through flight. Now, again, if I have to go Bangalore today, I will take flight early. It is going to take 3 hours. That means 40 hours and another day is 3 hours. So it was much more efficient. Same way, once you start using Docker or containers, you are hardly going to move back to these VMs or physical machines. And please remember, all of your students will be going to the industry. And when they will go to the industry, I'm 100% sure 90% of the students, when they will into the industry, within the first week, they have to use the containers. And again, when I'm specifying 90%, I'm little bit giving the figures, conservative figures. It is the ratio is even more. So please remember that whenever you have to deploy, till now you have attended a lot of sessions. Now we will see whatever applications you have learned how to create those applications, train those medical. But our purpose is, once we have created the application, how we are going to deploy. So the current trend is using containers, and please remember, container is part of your DevOps concept. So first of all, we want to see how to launch, install the Docker. So I will be sharing with you people how to install the Docker. So in my case, I'm not doing, because it is going to download a lot of software. So I'm just showing you the commands, because whenever you use Linux or Ubuntu, first command we always run sudo apt-get update, so that it can update the repositories. Then we have to install certain requisite softwares. I will be sharing these instructions with you. But the main command is this one, last command. This is, that means sudo apt install Docker. Now, Docker comes in 2 versions. One is paid version also, but we are using community edition, which is free. And then what we are using? We are using what concept also, Docker Compose. If you are not comfortable with running these commands, just run one command, apt-get install Docker .io. It will get installed. Hardly it is going to, and it is free. It will be available. In my case, let me go to that practical part. Now, first we want to check whether, in my case, Docker is installed or not. So once you have installed any Linux, in my case, Ubuntu Linux, the first command that you are going to run, that is Docker version command. So now when you are going to run this Docker version command, it will show you that one client is there and one server is there. And if you are getting error, permissions error, then please try to use the sudo keyword. otherwise. But in my case, I install in such a way that I do not require to use sudo keyword. So in your case, if you are saying that it is showing that client is okay, but server permission deny, then please try to use the sudo keyword. That means sudo Docker version. That means in our case, now this is installed. Now we have again told that whenever we have to create these containers, what we need images. So in our case, we want to download certain image. And please remember, this day we do not use the term download or upload. So the term used these days are, instead of download, we always call this as pull. Pull is the preferred word. And when you have to say upload, we are not longer using these terms in cloud days. We always say that we are pushing certain thing. So in my case, first of all, because I want to create one container, so first I need to download certain image. So in my case, I will run one command. I will say docker image pull, and I'm going to specify Alpine. Now, please remember, if I'm going to ask you people which Linux you use and what is their market share, in your mind, it will come that you're using Debian or Ubuntu or Kali Linux or Red Hat based Linux or SUSE Linux. These type of Linux will come into your mind. But please remember, there is one Linux which is getting very popular. The name of that Linux is Alpine Linux, and already it has captured approximately 12 to 15% market share. Let us see what is in this. So I'm saying Docker image pull, and I'm saying that means Docker is installed. Now for containing the containers, creating the containers, what I need image. So hardly it took 30 seconds to download. So let me check. That means once you have downloaded, then we are going to run the command. That means when I will be deploying those application, AI, ML or DL applications or computer vision application, what I will need certain image. So again, I will be running this type of command, docker image pull. You should only knew the name of that image. Then when we are going to say pull that image, that will be there. Now, because in my case, I have already got a lot of images, we just want to search about our Alpine image. So I'm just going to say, please give me the information of this Alpine image. Now look at this. That means you have got one Linux available. The size of that Linux is only 8.3 MB. That means if you are using the virtualization, you have to 700 MB, 1 GB, 2 GB. Here, sometimes even we are not satisfied with these. We want even small. So we have got another Linux available, again 5% market share. So what I will say, Docker image pull. Now from where it is pulling those images? There is one site is there, hub.docker.com. I will show you that also. So now we are able to pull that BGBox also. So in my case, I will say BGBox. We are trying to learn how we can pull the images. Then we will move to our that's a deep learning portion and computer vision. Now, if you are going to see, this image is even smaller than size. That means when you're using Docker, the smaller the image, better it is. So here, that means we have got one busy Linux is there, Alpine Linux is there. This level. So in my case, already 2 images are there. Now the most important thing is how to create the container. So let me go to, this is the most important, you can say, slide or concept, because images, millions of images are available. The problem is how to create the container. Sometimes it is confusing concept, because still you people are using physical machine. Please remember, most of the time when your students are going to industries, they will not be provided the physical machines. At least they have to work on virtual machines, or they will be given certain cloud instance. But I'm almost 100% sure that 90% of your students, they have to use the container. Please remember, when we used to have, suppose you are working on Python. Earlier day, what you used to do on physical machine, whether it is Windows, Linux, you are going to install Python, then you will use. Then the industry moved to the virtualization. That means you will create one VM. In that VM, you are going to install Python, then you will use. But now the industry has moved to the containers. That means whenever you are going to move to the industry, you are not going to use physical machines or virtual machines. 90% of the time, they will say, or they will provide you one container. They will give you one Python container, and you have to use that container. So be ready for these type of things. So in our case, what we want, we just want to check how to create the container. So what is the command? We will say Docker container. If we have to do anything with the image, we will say Docker image. But now we have already got 2 images available. One was BusyBox, one was Alpine. Alpine, again, market share is getting day by day, it is increasing. So the command is, Docker is the command. Then we are going to say container. Then I'm going to run this command run. And then I will go run this command I, mean interactive mode, mean please run the container, and take us to that container in interactive mode. T mean attach the terminal. Let me compare this with the VM. Now, if you are going to carefully look at this VM, I'm showing you 4 VMs. They are there. This is one VM, second, third. But if you are going to clearly look, only one of my VM is running. And in this VM, I can work also. In these VMs, I cannot work. That means already they have provided one terminal to me where I can type the command, and it is in interactive mode. So also, when you are going to use those containers, when you are going to create the container, you have to specify. That means we want to create in interactive mode, and please attach some terminal. And then we have to name that container. And when we say that name the container, I'm just going to give it C1. And please remember here what we have given. We have given, in my case, I have given Ubuntu. This is the name of my first VM. This is the name of second, third, fourth. That means we have to give name to those VMs. Same way, we have to give the names to the container. So I'm saying that please give the name C1 to that container. And then we have to specify. In my case, I'm using the machine. In my case, next example, I will show computer vision example. So in my case, I will say that please create container in interactive mode, whatever commands I'm going to do. And I might be giving the name to the container or not. Then I will specify the image. So in my case, if it is some object-oriented action image, then I have to specify that. Then here I have to specify the shell. If you have ever used the Linux, default shell is bash. But since these container concept, they wanted the images to be very small. So they created their own shell, which is very small in size. The name of that shell is Alpine shell. So we are saying that open this shell. Now, when we are going to run this, then what will happen? We will go. And please remember, if you are going to go to the, and if you are going to ask the Google about the container, they will give you one statement that every week we create trillions of containers. This is the Google statement. That means every week they create and destroy trillions of comments. Look at the scale they work. So here we are just going to look at. So first I'm going to create one simple container. Then quickly what I will do, I will move to that computer vision container. So what was the command? So I'm saying Docker And please remember, first of all, let me show you whether already some container is running or not. So we have got one command is there, Docker container ls -a, mean please show all the container whether they are running or stop. So what it is saying, no container is running. Now what I am going to do, Docker, we are going to say container, then I'm going to say that command run, then I'm saying interactive mode, then I'm saying you can say attach the terminal, then I'm going to say I want to keep the name. And please remember, if you are not going to give any name to this container, automatically one name will be given. Look at the scale of Google. If they are creating trillions of containers, then naming is very difficult. So most of the time we skip that tag. So in my case also, when I will be launching that computer vision application container, I will skip that name option. But here I just wanted to show. So, and then I have to specify which image and then which. So the moment I'm going to click, I'm already in container. So it was my host operating system. I'm in a container. So if I'm going to run this command, whatever is the command, so it is showing that I'm container. Again, you can run those commands there. You can create file. And if you do not want, just exit from this container. Then with LSA, it is showing that container is there. Now, if I do not need this container, so what I'm going to say, Docker container, I will say remove, and then name of the container. So you have to run the container, you have to stop that container, and please remember, if the container is running, first you have to stop that container and then you have to run. So that means you have to pull the image, create the container, and if it is no use to you, then what we are going to do, we will exit from that container. When we will exit from that container, what will happen? It will stop the container, and then what we are going to do, we will remove that containers, because in this case, whatever thing we do not need, we are going to remove. Now again, let us check. Now this is now we have to see how many images are available. So this is one site is available, hub.docker.com. So here I'm just going to search for Python. I'm just wanted to show you the scale on which the people are working. This is, and what it is showing, pulls 1 billion. And please remember, after 1 billion, they have stopped calculating. So that means almost each and everything you are going to visit here. Suppose I want to use Node.js. Let us see how many people have downloaded. 10 millions. Different varieties are there. So Java, anything, you will find that people are using these technologies. But the problem is, these images are bare images. Now, in my case, what I want Python. So in Python, it is showing that 1 billion. But in this Python, what is there? It is simply, it is having Python in which know that the TensorFlow is there or that type of thing is there. So let me move to my first application that I want to show. So in my case, I will go to this one, this computer vision application I want to show. And I will move to this. I want to, first let me show you the result, then it will be better. I want this type of thing. That means I want to upload one image. Suppose this is the image I want to upload. And I want to detect that face. So this is my requirement. Now, certainly I know that some of the experts, they have covered these type of things. But here we want to show how Docker can make the things very easy to you. And please remember, if we have to deploy this type of application, so we need certain libraries or certain software. So in my case, the way, in your case, the implementation might be different. So in this, I am using NumPy also. I will not go into the details of these technologies because past 5 or 6 days, you have learned a lot of these technologies. So in my case, I want to use OpenCV, then Flask framework, then certain dependency softwares are there. Then I want to use NumPy type of things. But the problem is, when you are deploying these type of the application, suppose I'm using this VM, what will happen if I'm using this VM in which Python is there? But what did I have to do? I have to run this command: apt install Flask, apt install OpenCV, apt install this package, apt install apt install this NumPy. And suppose in my case, I want to deploy 10 different applications in which I want, in one application, I want to use 2.1 version. In one, I want to use 2.2. I'm just giving an example. And I want to use NumPy different version. But traditional way, whether it is physical system or VM, when you want to deploy multiple of application, conflict will be there. And even if we have installed the application, it will work on my system. But when we will go to your system, it might not work. Even if it is working on your system, when we have to actually deploy that application for the people to use this application, certain problems, dependency, we call this as in industry, the people call this as a dependency hell. That means, or sometimes when your students come to you, they say, sir, it was working on my laptop. This is the common answer. And most of the time industry also, when they try to deploy, that means production deployment, then most of the time lot of problems are there. But when you are using this Docker of concept, what we do in Docker concept, we create one file. And that file's name is requirement.txt. I will show that file also. That means whenever we have to deploy any application, we will create one requirement.txt file. And in that, we will specify which thing we required, which version we require. So in our case, when I wanted to deploy these things, I have specified that I require this one, this one, this one, this one. In second application, it could be different. Like in this case, I have got another application is there where I have specified I need Flask, I need Torch, I need transformers, I need diffusers, I want this accelerate, I want this pillow type of thing. And sometimes it could be 10, sometimes it could be just one. So different, whatever there, what are my requirements, I will specify there. Then what I'm going to do, I'm step by step I'm showing. Now, sometimes there is a sequence. When you install certain thing, that means first we might have to install Flask, then this OpenCV, then NumPy, that type of thing. Same way, sometimes there is a sequence, particular sequence in which you have to deploy the things. So in our case also, what could I have done? I could have done that I will go to that hub.docker. I could have downloaded the Flask application. But most of the time, when you have to deploy the custom application, you will not, although millions of images are there, but you will not find that image which is suitable to you. So what we will do, we will create one Docker file. And this is very important. We will create one Docker file. So in this, what we are going to say, we will say, please pull Python. And we are specifying that we need one particular version. Then we will say in Python, please go to this directory. And whatever is in our source directory, put some code into there. Again, I will not be able to go very, very deep because of limitation of time. That means in our case, what the Docker file is going to do, it will pull one automatically. Like in our case, I was manually giving the command, please Docker image pull. But if I have created the Docker file, it will do the things for me, in which whatever instruction I'm going to say, when I'm saying from, it will pull that image. Then in that image, it will create the container and it will create one directory there. Then whatever software is there, suppose we have created one application there, it will copy that application into that. Then what we are specifying, we are going to specify, please install whatever is in that requirement file. So what it will do, it will install this one also, this, and this, everything it will install. Then we are saying on which port it should be running. So because Flask normally runs on 5000 port, so we are specifying. If you are already some other application is using this port, here you can specify 5001, 5002, but here. Then the main thing, we have to run certain application. So here we will specify that our application is APTED. So in this case, up to this point, what are we going to do? It will install everything and it will create one custom image for you. And then we want to discover about this app.py. App.py will contain your logic. So in my case, this is the logic. Again, I will not go into the detail, but a little bit explain. I'm saying that in this program, that import CV2, import this one, and then this is you load this pre-train this model. Then we are specifying if we are going to specify IP address or name of the site, and we are going to specify slash, please display this page. That means whatever code I am having, I will specify all the code. So what will happen? And in this case, and please remember, when somebody is going to access this application, I will run this application also. So what will happen? It will render index.html page. So in our case, we have created what index.html page also. Now that means what we are having, we have created one directory. Let me show you that. So I will go into the computer vision directory and I will run this command. This is the file. And in Linux, we have got one very powerful command is there. That command is tree command. It is going to show you the whole structure. So what it is saying? A.py is there, requirement.txt is there. Let me show you that also. So I will go into that, you can say app directory. And I will run this command. Now, this requirements is there. This requirement file. Then application file is there. I'm just showing that whole application. I will move back. Again, I will run this time. That might mean whatever you that means Docker file is there, requirement is there, your application is there, that index file is there. For test images, we have got certain test images are also available. And that let me show you that Docker file also. Docker file also. Now what is happening? That I have already shown that is Docker file. Now what I want to run this command. So please remember, whenever you are using the Docker command, Docker type of technology, you have to maximum run 2 commands, and your application will be ready. Whether it is a test application, whether it is a development application, or whether you want to deploy in production system, only maximum command that you need, only 2 commands. Whether you are running on your system or your desktop, or whether in cloud, any cloud, you have to just run 2 commands. And sometimes, even if you are thinking that 2 commands are much more, we can do with 1 single command. So in my case, let me run 1 single command. So I'm going to say, let me undo this. So I'm going to run 1 command. I'm going to say Docker compose, and I'm going to run 1 command up. Here I'm using single command. Later on, I will explain this also, because I first want to give one demo, then it will make the things even good for you. So what I'm saying, Docker compose up, single command. Now we will see what will happen. Now you will see 2 seconds, 4 seconds, attaching to web 1, and automatically it has created the containers. And if I'm going to show you what it is saying, your application is running on which port? It is running on 5000 port. That in hardly 30 seconds, my application is ready. So let me show you also. When I'm going to run Docker container ls-a, it is showing me. That means image, I was using this one. That means I have automatized certain process. That means by using it has automatically created the containers. Now, how to use this? So I will go into some browser. And one thing more, I just want to show. I want to show the IP address of my system. ENS33 is my interface. And this virtual machine's address is 192.168.142.138. In your case, it might be different. So what I will do, I will go to this. I will say 192.168.142.138. Then I am going to specify 5,000. Because our application is running on 5,000 port. Now what it is saying? It is saying that face detection. So in my case, what I will do, I will choose certain file. So let me go to let me specify this. So I will say upload. Now this image, it was able to detect. But what I want to convey, how much time it has taken. And if I'm going to give you that directory, that means computer vision directory, if I'm going to give to you, what do you have to do? You have to just run command docker compose up. It will be ready. Your application is running. Whether you will, if you are going to give real IP address, what will happen? This application will be available to all the world. And please remember, I will not give the exact name where we have implemented this. Now, there was one state in which they used to deploy certain application for their people, and it used to take, whenever they have to deploy the application, it used to take 15 days. And then whenever they have to update those applications, it used to take days. Then me and my team, they helped implementing these type of technology, and I'm talking about 5 to 6 years back. Now, whenever they have to deploy the application, hardly it takes 1 hour. And I will say 1 hour is even I'm again on conservative side. And if they have to update the application, hardly it takes 2 minutes to update the new versions. So this is available. So let me again go back, choose, second example. So again, it will detect that face. It is able to detect. That means my application got deployed. But here I want to discuss because we discussed about this Docker, but we did not discuss about this Docker Compose type of thing. And if I do not want this application, what I will do, I will press Ctrl+C. Deploying an application is also very necessary. And when you want to take down that application, please remember that is also because we want to clean up. So we have to run this command volumes. That means we want to say, please, if anything is associated with this application, please remove those all containers. If it has created certain temporary file, please remove this. So we will remove this. Now, in our case, when I was giving the example, we just used that command Docker. Here, it was not mentions about that compose command. So let me go into that. What is that Docker compose? And what is the purpose? And what we are in there. Now, sometimes what happens? Sometimes certain applications in which we only required one type of image, like suppose certain HTML page is there. And we can deploy HTML page by using your Apache container or your Nginx container. It is simple. We need just one container. But suppose you want to deploy database type application, database driven application. That means we will need certain Apache or Nginx container as a web server. And we will need one MySQL type of container also. And sometimes if you have to deploy industry level application, like these days, lot of mention is about that Zoho company. And please remember, in my case, I'm using the Zoho for the last 10 years. And I always used to say that one day it is going to be one big company. Last 10 years, I'm using that Zoho type. And they have got more than 200 different applications are there. So suppose in my case, I have to deploy those 200 applications. Then this method of creating containers, like we are creating this container one by one type of container, that is not the good thing. Then what we need, we have to deploy certain concept that is called Docker Compose. So I will just show you one. That means if your application is multi-container, if it is using multiple different type of images, then what we have to do, we have to use the Docker Compose concept. In Docker Compose concept, what we do, let me give a little bit more advanced example. That will be first day when I was taking one like a deep learning overview and computer vision overview. I showed you that I launched 3 applications. One was a particular AI application, rule-based. Then second was DL application, and third was ML application. And in my case, let me show you. At that time, I was having one Docker file. This was Docker file. So here, what I specify, I have specified certain instruction: AI app, ML app, DL application. And in this case, I have specified what should be the sequence, what should be the name of the container. And if you are going to carefully look, I am specifying here that this AI application should run on 5000 port, this should run in 5001, and this should run on 5002 port. That means if you want to deploy multiple applications, then we have to make use of this Docker Compose. And once you have created that Docker Compose, then what is the how to activate those 3 containers? We have to just run this command. Like in our case, which command we run? This was the command. So when we are going to run this command, what will happen? If I've specified 100 applications there, so what will happen? It will launch those 100 applications. And to my compose file, what I can specify? I can also specify, like suppose if I want to deploy PHP container also, Apache container also, MySQL container also, there should be a sequence of those containers. Our MySQL container should be running earlier. So in this Docker Compose file, we can specify, please depend upon, we can use one term, depend upon. Then what will happen? When we are going to run Docker Compose command, what will happen? It will first run that MySQL container, then it will create that Apache, then that type of container. That means it will go sequence-wise type of thing. So we can do. Now, before giving second example, I want to discuss one very important thing also, because then I will be giving you another example of this, you can say, how to deploy these applications using Docker Compose or Docker. Now, in my case, suppose I want to deploy web server. So in my case, I have already downloaded one image. So let me show you Docker image, ls, and I will run one command, grep, and I'm going to, please remember one thing. Whenever you have to deploy any website, to create any website, there are 3 main web servers are available. Number one is Apache web server. Almost 60% market share is there. Then we have got Nginx web server is there. Please remember, when you access Facebook, behind the scene, Nginx web server is running. And very few people use IAS server also, which is Windows-based. So it will be Apache or Nginx. So I'm just showing you one example. So in my case, I have already, I think, certain problem with the command, not images, it is image. So now in this image, I have got one file is there, image is there. The name of that image is Nginx, and the size is 152 MB. Most of the images will be from 4 MB to 100 MB, but because in this case, your operating system is also there, plus Nginx is also installed. So the size has increased a little bit, so 152. Now suppose I want to deploy the website. We are discussing this because when I'm going to give the second example of our application, then we need to understand certain thing. So that is why before moving into that application, I just want to give an example. Now I want to deploy that Nginx web server. And please remember, if in your case, if somebody has deployed this type of server, first what do we need to do? You need to install Windows or Linux platform or Mac operating. Then you have to install that Apache or Nginx. Then you have to configure those type of things. Then it will be able to run. But here we are going to see what will happen. So let me show you one command. So again, please remember, in our case, when I was creating this container, I was running this container in interactive mode because I have to work. Suppose you want to create a Python container. What you will do? Python, we have to work interactively. We are going to create those program. So sometimes we have to create the container in interactive mode. But sometimes, suppose you have to implement web server, FTP server, mail server. We do not have to implement those servers in interactive mode. And what we have to do, we have to run those servers in daemon mode, or we call this as in server mode. Same way, when I'm going to, that means there are two type of containers are there. One type of containers in which you are interactively you're going to work, and some of the containers will run in background. So whenever we talk about any web server, what we want the container should be running in daemon mode or server mode, or we can also say in background mode. So let me give one example of that. So in my case, my requirement is that I want to deploy web server. So what I will say Docker container run, and now I am not specifying that -IoT option. So mostly we will see IoT option, or you are going to see -D option. So in my case, if I'm going to run next command, if I'm going to specify -D option, that means I want to run all those container in daemon mode. So here, because which image we want to use? We want to use Nginx image. So we will say, please run this image in daemon mode. And we want to specify that name of our container is going to be web, because we want to launch. And if I'm not going to specify, it will automatically give. Then this I am not using this one. This is extra option. It is advanced option. This is very important. Now we know that our web server runs on AT port. So, but sometimes AT port is already used. So sometimes what we say, please, whatever your AT port container, expose it into AT port. Like in my case, my application was running in 5000 port. So let me give you one. Let me give you that example. So that will be much better. So in my case, I will go into one command. Okay, let me run. So let us first see whether we have already got certain containers or not. It is saying that we do not have the container. So now I'm going to run command. I'm going to say Docker container run. That means now we are moving towards creating complex containers. I'm specifying, then I'm giving one name. I'm saving that it is web or web server. Then this is very important. I'm specifying. That means, please, because containers port 80, expose that port with the 80 port of our host operating system. That means if I'm going to run my host operating system command, or if I want to access from outside the world, we have to specify this command -P 8080. This is container port. This is your host. Then what we have to specify? We have to specify that image. So again, let me show you. This was the command. This was the command. I have skipped this portion. This is for further advance. That means Docker container run d name. Here we have specified different port. I skip this and then the name of the image. Now in my case, what I will do, when I'm going to run this command, it is in background. And if I'm going to run this command, it is showing me that AT port is open. And what is the IP address? So I will go there. Let me close this one. And I'm going to type 192.168.142.138. Because in our case, we are just AT port. If you are launching your application in AT port, then you do not need to specify this port. What did he say? Welcome to Nginx default page. And if I want to specify custom, then I can specify. That means if there is certain application which is going to expose certain port, then what we have to do, we have to run this type of command, which is command, this one, this type of command. Now I do not want this, so I will stop. So this is, so I will say Docker container stop and name of the container. And please remember, if you do not remember that, just give this container ID. You can specify container ID also. You can specify that also. Why? Because our container is running. If the container is running, you have to first stop that container. Then you have to delete that container. Not delete, we use the term remove. Now let me again go to that. Now let me move to the another application that I want to show. So I will go there. I've got some other application also available. So let me go to this application, Deep Vision version 3. Deep Vision, it is V3 application. That means when I was implementing this, first I created first version, second version. Let me show, because in this case, I do not have the slides. So again, look at this app, certain code is there. Let me show you that code also. That means in app directory, we have got certain requirement is there. So here it is using Flask, TensorFlow, OpenCV, NumPy, Pillow. Then certain scripts are there. And then this application is there. Let me show you that also. In my case, I've created around about 30 to 40 different applications. Lot of, again, I will not go into the detail of this application. That means in this I am using NumPy also, and then TensorFlow also, Flask also. A lot of things I'm using. I'm using Pillow library also. Now the thing is, I have to launch this container. So in my case, so I just want to save certain time. So I will go into this. Now look at this command. I'm specifying Docker run. I will explain it a little bit on. Now, here we can specify this command also. This is a little bit old syntax. This is the latest. I'm saying Docker container run. And please remember, here I am not specifying that -- name web, because it is not recommended practice. Like when your house, when you have got cat, if you have got cat and dog, then we are going to name that cat and dog. But suppose in my case, if I've got 50,000 cows are there, I'm not going to name those 50,000 cows. So if it is in bulk thing, that we do not generally name those type of things, because when we create containers, sometimes the scale is very large. So I'm saying And in my case, this deep vision application, it was running on 5000 port, and I want to expose that 5000 port also. So in my case, I have specified, okay, please Docker container run -rm -p. Then I'm going to expose this port, and then I'm going to run this one. So when I'm going to say this, let me run. Later on, I will specify why I have run this command. I have specified -rm. So now we will see what will happen. So in this case, again, my application will get launched on this 5000 port. Let us see here also. So now what it is saying, that means our application got launched. So in my case, what I will do, again, what is the IP address? IPAS. Last 50 minutes I will keep for them you can say for the question answer. So this is my address, 192.168, same address. So let me clear this one. Or let me give a little bit ENS33. This is my address, IP address. And then let me show you container information also. Which is the command? Docker container ls-a. This is the command. Now, the way I have implemented, it will download certain things. It is taking later because it is a certain pre-trained library that model it is using. So it will download that, and again it will expose that application at 5000 port. So again, what I will do, I will go there. So here, what I am going to specify, I'm going to specify. That means in my case, one application run on 80 port, another can run on 5000 ports. And look at this. Even although this is not fully implemented webcam type of thing. So in my case, I will just upload the image. And I will give the photo of suppose cat. So I will say upload. Now what it will do, it will classify. That means it is specifying that chances of it is this type of cat, Egyptian cat. This is the. Let me upload another image. That means that classification. First day I have shown you certain different application. Now again, let us go to this. So in this case, it is correctly, and it is with how much confidence it is showing. And then let us open one another. So because my webcam is running there, so I will not try to use the issue could be of hanging. So it is correctly able. So again, that means look at the way we are deploying the application. It is hardly taking any time. And when I'm going to say cancel. Now, let us check about the container. Because earlier what was happening? Once we are going to cancel that, then we have to remove that container. Now, you will see that automatically the container got removed. Why? Because during creation time, I was using that command -rm. I was specifying, okay, please Docker, if somebody is going to cancel that container automatically, don't bother me, please automatically remove that container also. So sometimes we want to save our time. So this is another application that I'm showing. Then let me give another application. The application that we run on the first day. So I will go to this. Now, here I'm not running one application. I mean, look at the beauty of this concept. And please remember, if you're going to go to the car showroom, and if you're going to buy some car, suppose they are saying that this car is with 3 tires. No. Whichever car or vehicle you are going to purchase, 4-wheeler, it will have at least 4 wheels. And sometimes stepney also there, although in some of the models they do not supply that stepney. That means 4 tires are necessary, wheels are necessary. Same way, when your students, they are going to go into the industry, Docker, and for 5 minutes I will discuss one another concept. They are compulsory. It is compulsory 4 tires. They have to use this. I have seen whether they are from one average college or from a very big college, reputed college. When they go to the industry, I have seen their blank faces because they know a lot of things, but they do not know how to deploy these in production type of things. So when you have to deploy this production or type of thing, 90% time the people will go for this Docker technology. And one sister technology is there, which I will discuss for 4 to 5 minutes, that also to make. But now we want to deploy these 3 applications, and I'm showing you that Docker Compose file. Now, one application, because if all the applications are going to run on that, you can say 5000 port, then it will be conflict. So in our case, we are saying, although in container that applications, all the 3 applications could have been running in 5000, but we are saying that please run this application on 5000 port, run in 5001 port and 5003 port. So here I'm going to run one command, Docker Compose up, and then I'm specifying -d. Now you know why I have specified -d, because in this case, what I want that all 3 applications should be running. And then what I want, they should be in daemon mode. So we can use one command, ps or ls. It will show you how many, which file I'm using. Then we can use ps command. It will show you how many containers are running. And let me run that also. So it will make you the first day. So in my case, 3 applications are running. So in my case, I will give you the 2 examples. One was our, one was AI application. So let me run this command. I'm just extending that session. Here it is specifying. I have already given this time. Second was that was machine learning application, where we were using the iris dataset, and it has predicted. And third was our cat and dog application. So let me show you. So here what I will do, I will try to detect that application. What it is saying, I think I put certain wrong thing. Okay, let me cancel this one. Let me run this command. Again, I have given this example. So let us see what it is going to specify, whether it is a cat or. So it is saying that it has according to that sort of the chances that it is Egyptian cat 80%. Now what I want to take down those. So what we have to do? Compose down. Then I'm going to say minus volume. So 7 minutes more than 15 minutes I will take for the question answer. Now in this case, what is happening? I'm just missing one step, or I have not shown you that. Please remember, this is the command, but in actual, you have to run another command. That means whenever you have to deploy the application initially, we have to run this command. I told that at least you have to run the tools command. Why I have not shown here? Because in my case, if I'm going to run this command, it is going to take 10 minutes. what happens when we run this command? This should be the first command. What command? Docker compose up build. What it will do? It will take that Docker file and it will create one images, 3 images different, AI application different image. So it will take time. Or if we want all the things to be running, that it should build the images also, it should run those images, then we have to specify this type of thing. So, but first time we will run this command. Then second time, you do not need to run this command build, because if we are going to say build, what it will do, it will again run those commands. Again, it will try to download that pillow library. Again, it is going to do all these types of things. Let me show you one command. Then we will 5 minutes. I will discuss another concept. Then I will take the question. Now, if you are going to see, in my case, I created one image that size was 1 point, because in this lot of TensorFlow was there, Pillow was there, so different application. And when I'm running that command, it is creating 3 images. One's size is 2.23, one's size is 466, and this is. Now, let me just for 5 minutes discuss another concept. Then we will close this. Then I will take the questions. So let me move to one slide. In my case, I'm opening this one slide, and then I will open another slide. Now, suppose we are finding that this application is getting viral. That means the application that we were deploying object detection, it has gone viral. This day, it happens sometimes your applications get viral. Now, the problem is, if my application is getting viral, if only 1 copy is running, what will happen? Within a few minutes, because so much load will be there, that means it will be down. Now, what I want 1000 copies of that application. So there is one concept, another that industry uses. That concept is called Kubernetes. That means, now in our case, what we were doing, we were having one VM. Suppose if I've got 3 VM, or not 3 VM, I've got 50,000 different VMs, or 50,000 different, you can say, physical system. And I want now that my 50,000 applications should be running of that my viral application. So what will happen? We have to launch those 50,000 systems. Once we have launched those 50,000 systems, first I'm taking the example of 3 systems. Now we need certain, in the first system, Docker will be running, second system, Docker will be running, third system, Docker running. We have to individually manage this system. But suppose if these are 50,000 systems, what will happen? We need certain software. So another software that industry uses when you have to scale, that is Kubernetes. Again, without Docker and Kubernetes, there is no survival in IT industry. ये मैं पत्थर पे लकीर की तरह, written in stone, I'm saying. What is the Docker, this Kubernetes is doing? Kubernetes, if you have to deploy the application in scale, automatically it controls. And the beauty of Kubernetes concept is that if I'm going to give command to Kubernetes, please keep 50 copies of that applications running always. What it will do, you do not have to interfere. If 2 applications are down, automatically, or 2 instances are down, automatically it will launch new instances. That means once, if you are specified now, like in the case of that Atari app, that was, they were saying that lot of load was in their server, and we are trying to update our servers. So basically, if we are using Kubernetes, just we have to run one command, Kubernetes, please make the copies from 50 to 5,000. Within minute, it will raise the copy to 5,000. It will raise those copy to 50,000. So when you have to deploy on scalable, then we use Kubernetes also. If you have to 2 or 3 copies we have to implement, then Docker is okay. But if we want scalable application, then Kubernetes is that. And please remember, Kubernetes was created by Google itself, and they open source this, and half of the Google runs on this Kubernetes. Please remember that. So now in my case, I will not go further. I will take the questions because I want to finish at 3:30. Don't want to take the extra time. So participants, any questions you are having? Participants?
Hello. If a participant have any question, so participant can ask the question to our expert.
Because first day a lot of question was there, so I thought keeping dedicated 10 to 15 minutes for the question. That is surprising because first day a lot of questions. So participant, any questions?
Good afternoon, sir.
Yes, ma'am.
Sir, to all the platforms or for all the tools, we can use Docker?
Yes, most of the things mean Docker and Kubernetes are the standards. So if you have heard the term DevOps, the companies are using, and when we talk about Docker and Kubernetes, 50% of DevOps part is Docker and Kubernetes. And each and every industry, they have to use 90%. I've said that is again, that means each and every industry, when they have to deploy these application, they use. And in cloud also, like imagine people, they have started EKS service, Azure has started AKS service, and Google Kubernetes engine service is there, that been Kubernetes engine, and they are using. Or if you want to use open source, then OpenShift is there. So almost all the industry in all type of application, they are using the Docker. This is industry standard. I've seen a lot of time, in my case, from the years I'm using these type of things. And most of the time when we are doing the industry training, half of the time we get request on this, how to containerize or Dockerize your application, or how to deploy in this. So these concepts, you have to learn these type of things. So my purpose was that when you have learned a lot of topic, how to integrate this. So that is why the term I use embedded. Embedded mean Docker, everything in embedded in that image. But if you have to deploy in 100 scale, then Kubernetes is the another concept.
Yeah, thank you, sir. Actually, I'm a little weak in deployment, so this session is very useful for me. Thank you so much, sir, for providing this session.
Thank you, ma'am. Other participants, questions? For most of you, this might be a little bit new when we are talking about Docker and Kubernetes, but you are going to heard this term lot and lot. If you're going to talk about your student who are already in industry, and they will mention this word that, yes, we are using this. Other participant, any questions?
Sir, please share your email ID or contact numbers.
Okay, ma'am. Let me. So this is my phone number. It has not changed from the last 20 years, so no chance. Let me just verify.
Thank you, sir.
This is. And participant, if any other question, I will again wait for, otherwise we will conclude the session. And let me share you one channel also. So if you want further knowledge about Docker and Kubernetes, I put more than 50 videos on you can say, on Docker and Kubernetes on this full courses I put on my channel. So let me. Any questions, participant? Actually, I think Saturday is today. Gautam sir, I think there is no other question.
Maybe.
Participant, please free to ask questions. You can type also.
So if a participant have any question, so they can ask the question. Otherwise, we can conclude the session here.
Gautam, I've kept 15 minutes for the questions. So,
Okay.
if I have known, so I could have continued with that session. So another 1 or 2 minutes we will wait and then. Should I conclude, Gautam?
Yes,
Or
if a participant have no question, we can conclude the session here.
2 or 3 participants, they can say that no question, then we can conclude that. Gautam, I'm concluding that session because participant
Okay,
almost.
okay. I think there is no question, so we can conclude the session here. Thank you, sir.
Okay. Thank you, Gautam.
Nice deliberation. Okay,
Okay,
thank you, sir. So next session will start within 10 minutes. So thank you. Good afternoon, madam. Hello.
Good afternoon, sir.
Good afternoon. So, madam, our previous session already over, so we can start now, no?
For me, it is fine, sir. But if participants need a short break, accordingly, you can think.
Then we can take say 5-minute break, and after 5 minutes we will start. Okay.
No problem, sir. No problem.
Okay. Okay.
Okay, sir.
So good afternoon, all participants. Now we have with us expert speaker, Dr. Jagriti Saini, madam. So madam will take session 12 on traffic light detection using OpenCV and CNN. And Dr. Jagriti Saini is a founder and owner of the organization Eternal Restem, and she have more than 11 years industry experience. So madam will take this session 12. So madam, please, you can start now.
Sure, sir. Thank you very much.
Thank you, madam.
So good afternoon, everyone. I'm sharing my screen with all of you, and we'll be starting with a session on traffic light prediction using OpenCV and CNN. And for this today, I'll be first using some synthetic data set. That data set we'll be creating using Python programming itself. And then we will use some real images also for making predictions further. So step by step, same as yesterday, we'll be doing experimental analysis. I'll not include any kind of theoretical discussions over here so that you can have complete practical understanding of the topic. I request you all to kindly mute yourself if there are no more queries. So in order to start with, I suppose that all of you must be having your computers or laptops with you so that you can do it with me, same as yesterday. That is, of course, the best way to learn things. And there may be several libraries, etc., that we will use same as yesterday's session because few things we'll be doing in the same pattern. But yes, there will be some new things also depending upon the topic that we are addressing today. Definitely several new things also you will learn. And the most important part you will learn in this session is to create synthetic data set, like creating data set with your code itself. We'll be creating simple traffic light data set only, not a very complicated data set, but yes, just a basic data set to train your CNN model we'll be creating here. And that data set creation we will do with the help of OpenCV. So for that, we'll just go to Google Colab first of all. All of you can follow the same procedure. We will search for Colab first of all, and you will be able to find it using the official platform here. So I can click on this. If anyone missed it yesterday, the same pattern you all can follow. You just have to log in here with your Gmail account, and then you can go to the file option and then new notebook in Drive. Those who are implementing it side by side, I hope you are able to follow. So new notebook in Drive, after creating your login using Gmail, then only you will get this option. And once you click on it, you will be taken to a new window. That will be your coding window on this Google platform. So I'll be just closing the previous one, and this coding window I'm keeping here. Where we'll be setting up all the essential libraries, etc. We'll be getting all the necessary step-by-step coding procedures here. So we can rename this. I'll write here traffic light prediction. You can give your project any name as per your choice. I'm just giving a simple name over here. And in the very first step, we will get few essential libraries. We will just try to import them so that we can use them freely throughout the session further. So to do that, I'll first use a text cell here. And inside this, I'm inserting the first step, that is to import necessary libraries. And same as yesterday, I'll be sharing all the codes in the chat box side by side, so that those who are implementing it with me, they can get them easily. So no need to rush with the typing. Rather, the things I'm explaining that you can listen carefully. Just try to understand every part. And for your execution, the code I'll be sharing side by side after it gets executed on my screen. So first of all, we'll do here import CV2. That is your OpenCV library. It is named as CV2 over here. And the second library we'll need is NumPy. Yesterday also we have used NumPy library. So NumPy we need for any kind of numerical manipulations on the dataset. because we are dealing with some image processing data set, and in that also the images are generally presented as matrix containing numbers, and in order to process anything over that matrix, we need NumPy. Similarly, I may need to plot some details while processing this project. So for that, I'll be using matplotlib library, and I'm giving it a nickname PLT here so that I can call it with this nickname anytime whenever I have to plot something. Then I'm just importing it TensorFlow as TF. So for the TensorFlow, I'm giving nickname TF. And other than this, because we'll be building CNN model, a basic CNN model we'll be building. So for that, I need Keras models as well as layers. So for that, I'll just go to TensorFlow.keras.models. And I'll first of all import a sequential model to set the base of my CNN model. And then from TensorFlow.keras.layers, the next thing I'll import is convolution 2D layer. If any of you have worked on CNN models earlier, there are multiple layers that help us to create a perfect CNN model. It includes multiple convolution layers, pooling layers, you have flatten layers, dense layers, dropout layers. Each one of these layers have their own impact in a CNN model. Currently, I'm uploading these layers. I'm just getting all these layers ready here. And when building CNN, I'll be also explaining each one of them, how they are going to help you or why we need them in the CNN. So while we'll be building CNN model, then we'll be discussing each one of these layers also. So currently, the next layer I may need is max pooling layer, max pooling 2D itself. Then I'll have a flatten layer, then a dense layer, and a dropout layer. These are the necessary layers that I may need right now. Otherwise, there are a few more layers also that as per requirement we can alternatively use here, or we can change some patterns depending upon what type of model we are creating. These are just the most essential and basic layers that we may need right now. Then from TensorFlow.keras.utils, I'll be importing one more function that is toCategorical. This function I may need further to encode my class matrix. Currently, if I have some binary class matrix kind of patterns, we may encode them by using this toCategorical. We can convert it using one hot encoding process. So this toCategorical function further will be utilizing to setting up our class matrix. So currently, these are the essential set of libraries that we may need. I'll run it and I'll use all these functions and libraries one by one further while setting up the remaining program. So I'm just running this first part. And if this works fine, I'll be sharing this set of code with all of you. The first set of code always takes some time for execution because in this process, it has to set up connection with your Google servers also. I can see some typos here. Let me just correct this one. I can see here. TensorFlow looks fine. I'll just rerun it. And now I got the green tick mark you can observe. So I'm just taking this one and I'll be sharing it right here. All of you can get your libraries ready and let me know in the chat box quickly if you are ready with your libraries. Then I'll be setting up the remaining functions further. Those who are doing it side by side, they can be responsive in the chat box. Okay, I cannot see any responses. So I suppose no one is implementing side by side. If anyone needs any help in between, they can let me know. They can post in the chat box. Otherwise, I'm just moving to the next step. And throughout this program, I'll be creating multiple functions. So first, every function I'll explain to you. I'll just set them up in sequence. And then ultimately, I'll be deploying all those functions in a single sequence. And after that only, we'll be able to see the outcomes of those functions. If anyone is doing Python programming for the first time, it is important to mention that when we create functions, at that time, you will not be able to identify if there is any error in those. I request you all to kindly mute yourself if there are no queries. Thank you very much. So when we deploy those functions by the end, then only we'll come to know about the errors associated to those functions. So I'll first try to create the functions here. And in case if any error occurs, we'll be correcting that later on also. So don't worry about that. First, try to understand what different parts of this code I'm creating here. The very first thing I'll be setting up here is, thanks for those who are responding in chat box. That is really helpful to understand if anyone is doing on the other side. So I'm using a function to generate synthetic dataset on traffic light images. So just some sample images of traffic light I'll be creating. These will be just some basic images, like only a circle of different colors will be creating. But still, with that kind of synthetic data also, when I train a model, I later on will be able to predict some real images based on that. So that difference also we will see, that how even with the help of a synthetic data, we can train a model and then we can make prediction over real data also. That is also possible. So we will be learning that part here. So for this, the function I'm creating is generate traffic light dataset. This is the name of function I'm giving. And inside this, I'm passing a parameter, number of samples. And by default value I'm giving is 300. So sometimes we pass function parameter value while creating a function itself. And this is like already given value. Default argument we are passing here with value 300. Now, whenever we'll be calling this function, if I pass a specific value to num sample while calling this function, then that value will be considered for the execution. Otherwise, it will be taking the default value 300 every time. This is how these kind of arguments work. So later on, if I change this value to some other value like 500, 1000, 2000, then that number of sample will be created. And if I do not pass any value while calling this function, then this will be considered as default value and only 300 samples will be generated. So these are different ways to create functions in your Python platforms. Then images. First of all, one empty list for images I'm creating. Then one empty list for labels also I'm creating. And then here we have light colors. And because we are working on traffic light, so we all know the different colors that are possible. Red, yellow, and green. Maybe 3 colors I need. Later on, if you are working on some other project, then accordingly the colors you can update in that. Currently, I'm putting here 3 different colors. Now, inside this, I'll be generating the images. For dash in range, number of samples, whatever number of samples we have passed while calling this function, those number of samples will be passed here. I'll write here number of samples itself. And here I'm using a dash, underscore, we can say, underscore I'm using. When we are using a throwaway variable, then we pass underscore here. In case if you need this return variable, then you can pass a value, a specific maybe alphabet or a specific word here that in which you want to store those entries. But currently I'm using it as a throwaway variable. I don't want to store anything about this in the memory, but just for the runtime, we need this call to complete the number of samples based executions. So that is why a simple underscore we are using here. So in the next step, what I'll do is I'll first create an image with a blank background, because on that I'll be putting up the traffic colors. So first image I'll be creating with blank background, and that will be created by using np.ones. Inside this, a dimension of 64 cross 64, 3 I'll be using. That is a 3-channel image with 64 rows and 64 columns. So accordingly, the sub values will be fed in your entire sequence, and 3-channel means your RGB color sequences will be used. So a colorful image later on we can put on this. But currently in the first step, we are just creating a sample version of blank image. So uint8 I'm writing here, multiplying it with 255. So what it will do is it will create a matrix of ones with a size 64 cross 64, and then we are multiplying it with value 255. That will help us to create a grid that contains 255 score, which represents your bright color. Complete bright means a white background basically, which represents. So that will be automatically creating a blank or a white background image, we can say. In the next step, what we will do is we will put up the label sequences, the labels that we need for these traffic light creations. I'll write here label is equal to np.random, and we will make choices, random choices, and that random choice we will make from light colors that I have stored here. So 3 colors I have already stored. So from these 3 colors, I'll be making random choices. Length light colors, what it will do is, it will first calculate length of this list. So we have 3 entries here. So that returns your sequence with index 0, index 1, index 2. 3 values will be there basically, 0, 1, and 2. That represents this 3 element sequences available in your list. So here, random choice, it will make one by one. If it is picking up the first value, the label will be 0. If it is picking the second value with the random choice, the label will be 1. If it is picking green, means third element, then label will be 2. So considering this, if I have to make selections now, if label is equal to 0, in case if the label is equal to 0, that means red. If it has selected red, then what I'll do in that case, I'll write here cv2.circle, a circle that will display my traffic light that I'll be creating. Then image, inside this 32,20, this is the position where I need that circle over your X and Y axis. So 32 represents your position on the X axis, 20 represents your position on the Y axis. Then radius of the circle I'm passing here is 10. And after this, the color pattern to represent my first color sequence for indicating red that I'm passing here. And this -1 will ensure that that particular circle of radius 10 is colored with the specific color that we are mentioning here. So this is the first level. Now, in case if I get the second color, I'll put up here the elif condition. Then I'll put up here elif label is equal to 1. So in case if the label is equal to 1, that represents your second color, yellow. From this list, 1 represents your yellow color, second color basically. Then cv2.circle again we will pass here. And in the same pattern, I'll just change the color sequence to yellow. 2 positions I'm filling this time. So this will represent our yellow color next. And then we have the third condition, elif if label is, so this one I failed to write here 1. We need 1 here. And then 2 we will be passing. So for this we have the green color, and I'll be passing here circle imj. And again, the same pattern we can use. I'll just replace 1 value to represent third color. So that will be 0, 0. This middle one will be 255 and last one 0. So these three settings we have updated here, representing three different colors that we will need in our data set. So
Excuse me,
once
ma'am.
these, yes, please.
Ma'am, this will generate the Excel table or images of these three colors.
We are
What it will
generating
generate?
we are generating images right now. So this
Images.
time what it is doing is this circle pattern it is creating for now, and that will be
Okay.
in the form of the matrix that we have, for which we have created a blank image earlier with
Can
a
we
64
generate
cross 64.
can we generate means synthetic data set for real time images also? For example, different kinds of dogs images. Can I generate synthetic data set for that also?
For that your code will be little complicated. This is the simplest code we are writing, but for that you have to create the entire structure of dog itself. So it is
Okay.
possible, it is not difficult, it is possible, but yes, the entire color pattern you have to adjust accordingly.
Okay. Is there any library that will means adjust by itself, like random module or something like that?
I guess there should be some libraries I have not used, so I'll not be able to suggest you right now about that. But I
Okay.
can check, and possibly if I know any answer for that, I can share with your coordinator and they can guide you further.
Like your Python random module or NumPy random, can they generate such kind of things
See,
randomly?
random modules have plenty of functions inside. There are like hundreds of different functions you will find. And possibly out of them also some functions may be suitable, but it is not possible. Like straight away, I cannot tell you that that particular function is possible for this thing. Because
Okay,
generating
fine.
synthetic data set requires combination of multiple functions. It is not possible with a single function itself.
Okay, fine, ma'am. Fine, ma'am. Thank you.
Okay, ma'am. So after generating these patterns, I'll append this to my data set. You can remember that I have created two empty lists earlier. Now I can append all these updated image sequences to these. So for that, what I'll do is images.append. This one I'll be appending first. And inside this, I'll be appending all the images that we have created here one by one. These all images that we have created, they will be appended in the image sequence. And then second thing, labels will be creating and they will be appended in the label sequence, because we have created these labels right here, and in the same pattern they will be appended into the next array. So once we have appended these images and labels, now we are ready to set up these image arrays in the normalized spectrum. Generally, when we want to display these kind of synthetic images, we may need them in the normalized form, because that is the best possible outcome you will find from these functions directly. And for that, what I'll do is, first of all, this level I'll update here. We need this appending sequence at this level, and at this for loop level, I'll be updating here. Images is equal to np.array. Inside this, I'll be passing all the images. Then AS type, I'll update to float 32 for better representation as we may require. This is for better display further also, and as well as to process your data in a fine sequence into your CNN models. So we are just normalizing it. It is a kind of pre-processing we are doing, normalizing to 0 and 1. So that kind of process we are doing here. So np array images dot s type I'm updating, float 32 we are doing, that is fine, and divided by 255.0 I'm updating. In the next step, I'll be updating here labels is equal to np.array, and this one also labels. So in the form of arrays, basically, I'm updating all these sequences one by one now. And this will help me to return images, labels, and light colors. 3 elements in return we'll try to find out of this. Let me check the error sequences, why they are appearing here. This is the level for define. Yeah, this should be fine. Just an indexing issue we were having. So now this should be fine. All three levels we have updated here to generate synthetic data set. I'll be running this portion. Note that, as I told you in the starting phase, that if we have any errors in the function, they will not be visible right now. Currently, we will get green tick mark for each one of them. But if there are any error in the function, when I'll be deploying these, then only we'll come to know about that. So currently, you can just execute it side by side. And if we have to do any corrections, we can do that after deploying these functions also. Still, I'm sharing these codes side by side because I hope that they are error free up to this, because I cannot see any possible mistakes on the code right now. Now, in the next step, what I'll do is I'll write here function to pre-process dataset. One more function I'll be creating here. And in this step, what I'll do is I'll do just two steps. One is because normalization I have already implemented here. In the previous step, normalization I have done, that was also part of pre-processing. Otherwise, we could have done it here also. That is our choice, how we want to set up our functions. So in this step, what I'll do is, one thing I'll do is one hot encoding for the labels. Because for setting up a CNN model, generally one hot encoded labels are preferred for better accuracy. So I'll be converting my labels into one hot encode, like from these simple red, yellow, green, I'll be getting numerical form of labels. How one hot encoding works basically. For instance, if anyone is new with one hot encoding, I can share quickly over here. It will help you to set up all the variables available in your target variable ones. For instance, I have three color sequences here. That includes your red and yellow and green. Three colors basically we have. So this is the general representation for our labels right now. After I one hot encode this, instead of providing these values like red, yellow, and green, for instance, if generally my labels are appearing like red, yellow, green, and maybe further sequences of this we have like again yellow, then green, and then maybe red again. Maybe this kind of sequence we have for the labels. So instead of presenting them with these alphabetical sequences, if we do one hot encoding, what it will do is it will provide three level for representing these numbers. And how that will be done? R, G, B. Wherever I have a red color, it will show 1, 0, 0. Sorry, 3 I have to update, that is yellow, and R, Y, and G. These are the colors that we need. So from these encoding, wherever we have red, 1 will be there, 0, 0. Then this will be represented in this form. Green will be represented in this form. Yellow again will be represented as this, and then green as this. So this kind of pattern will be created to represent these alphabetical orders. So after this, your data will be presented, the label data set will be presented something like this. So instead of providing a single sequence or alphabetical sequence, we generally present our labels in the form of one hot encoded sequence. Although this increases the storage requirement because we are using now 3 digits to represent single variable. Every time 3 digits we are using to represent single variable, but still this is one of the most preferred format when we are building CNN models, and accordingly we can do this conversion. So in order to set up this kind of coding, what I'll do here is, in the very first step, I'm just using a pre-process function here. I'll be calling it pre-process underscore dataset as function name. Then inside this, I'll be passing images, labels, and number of classes, that is equal to 3. So I can mention that here itself because we have 3 classes in our prediction, that is your traffic light colors. So in the first step, I'll be doing one hot encoding for labels, and that is very simple. Labels I'm updating with 2 categorical. As I told you right in the beginning, this we have imported initially as one of the functions here from Keras itself. We have used to categorical. So I'm just calling that right here. And inside this, labels with reference to number of classes. Since we have 3 classes, so accordingly, it will do one hot encoding as I have shown you on the whiteboard right now. So all the labels will be updated accordingly. Second thing I'll do is split data into train and test sets, these 2 portions, and possibly I'll use 80-20 split. Today, I'll be using only training and testing data set. Later on, possibly you can use validation dataset also. I'll be creating just one basic model today that will have only a training and testing dataset. Yesterday, I have explained every part to you. Otherwise, based on that validation dataset also you can create. That is just another split you can put over your training dataset, and accordingly you can pass it to the system. But currently, since we are working on the synthetic dataset only, so I'm just using 2 portions only. That is enough to test my variables. And here I'll be using split IDX variable. And inside this, I'll be passing my ratio as required, 0.8 into length of images. That will help me to create this 80-20 split, means 80% out of length of images. So if length of images is like 1000 images, that means 80% means 800 will be used for the training and remaining 200 will be used for the testing purpose. So that kind of split IDX I'm creating here. And then I'll be setting up my X train and X test variables. And here also Y train and Y test variables I'll be updating. So in this section, images I'll be updating. This section split underscore IDX I'll be updating. Then images split underscore IDX. So what it will do basically, it will help us to update the sequences. This one will require index. So first 80%, this one will go into the training set, and then remaining 20% will go into your testing set. So these 2 portions will be creating here. First 80% into training, and then last 80% remaining one into the testing phase. Same will go for the labels also. Here I'll be creating labels, and here also I'll be setting up the split IDX as we have set it up it in the previous level. Labels here also split underscore IDX, the remaining ones. So all required 4 portions from this data now we have created, and it will return us 4 things. One is X train, other is Y train, then it has X test, and then it is Y test. So 4 elements will be returned by this preprocessed dataset function. First, encoding our labels, then splitting our training and testing dataset into 80-20 ratio, and then returning all these 4 variables as the result of this deployment of this preprocessed function. So I'll run this one also, and this should be also ready. I'm sharing this one also in the chat box right here. Let me first know if we are clear up to this level. Then accordingly, I'll be building up the next essential function. If anyone can respond in the chat box. Okay, thank you very much, sir. So next function I'll be setting is to build CNN model, a basic CNN model I'll be setting up. So function to build CNN model. And inside this, I'm writing here build underscore model, and then input underscore shape, num underscore classes. So for build model, two things I need. One is input shape, and second, number of classes I'll be passing here. So inside this here, I'll pass model is equal to sequential. Sequential model is your base element in CNN creation. So that we have set it up here. And now every layer one by one we will pass. So the very first layer we generally pass while creating a CNN model is your convolution 2D layer. So this one I'm passing. This is the most essential layer that takes your images as feature map inside. It will accept them as a feature map. And then it will also deploy a sliding filter or a kernel over your 2D input that is taken as an input by the system. So convolution 2D first I'm writing here. Then 32 I'm using here as the number of neurons I'll be setting up on this convolution 2D layer. And after this, the kernel size of 3x3, that is your filter size or sliding filter size for processing your 2D input, that I'm using a filter size or a kernel size of 3x3. Then I'll be passing the activation function. Generally, by default also it is ReLU, but I have mentioned it here as well. Otherwise, you can consider the by default functions also. Then input shape I'm using input underscore shape, because that I'll be mentioning while setting up or while calling this function. So here I'll be passing input shape in that case. So the same shape it will be passing here as well. So it is our choice whether we want to create a default value initially or we want to pass it while deploying a function. So whatever I'm doing here, this is an optional way to set up your models. There are like hundreds of different ways also to do the same thing. It is not like only one way to set up your model. I'm just using one technique that will be setting up your CNN model using a build function. Otherwise, you can use other methods also later on. So after setting up first layer, the next layer I'm putting here is max pooling layer. Max pooling 2D layer. And inside this, I'll be passing a filter size of 2x2. So this is to set up the stride size for your 2D layer. So whenever we are working on CNN models, every time we are trying to downsample the input matrix. And that is done with the help of several filters applied one after another. Generally, when we are working on a simple CNN model, like for instance, if we have a large matrix of data, there may be any big matrix that is containing maybe any number of values. Currently, we are presenting them as your values between zeros and ones instead of 255 because we have normalized them already. So there may be some values like this, just putting some random entries here, 0.2, maybe 0.3, then maybe 1, or maybe 1, 0.3, 0.2. These kind of values may be there. So in the very first layer, when we are having convolution 2D, there is a very big matrix of this. Initially, if you know, we have created a 64x64 matrix. So 64 towards this side, 64 towards this side. That is the size of matrix right now. So when we are updating the first convolution 2D layer, 3x3 kernel size we have adjusted there. So that 64x64 matrix will first be processed through a 3x3 kernel. And that kernel may take up values something like this. These 3 levels it will be processing one time. And then this kernel shifts further. This will be its next level. And then it will shift further. This will be its next level. Depending upon how many values we have, it will go further. So one by one, this kernel will keep on shifting. And from here, it will be creating, there is a mathematical phenomena that works behind. And it will be creating a single element value out of this. So after processing all these elements, it will return a matrix of little smaller size in comparison to 64x64. So there may be another matrix that may be little smaller, and that will be getting values from this, depending upon the mathematical function that is working behind. Maybe you will have some new value 0.8, 0.4, maybe 0.2, etc. Depending upon the size of kernel that we have passed, a matrix that is smaller than this will be created. After this, the max pooling layer is applied. And in the max pooling layer, depending upon the stride size, for example, if anything like this we already have, maybe these are the general values I'm creating here. So I'm setting up a stride size of 2 × 2. So it will be taking this one as my first filter for a stride size of 2 × 2. Max pooling means maximum element out of this. There are different ways of pooling. Average pooling is there, min pooling is there, max pooling is there. When we are talking about max pooling, it will identify the maximum possible element from this, and maximum possible right now is 0.8. So in the next level, when one step further, it will be reduced. In the CNN, that matrix will be further reduced, and the first element may be 0.8. Then this stride will be further moving, maybe to this level. And from here also maximum possible element will be identified. So that is 0.4. So next element here will be 0.4. Then accordingly, this stride will move further and further towards horizontal and vertical sections. And maybe at some point it will reach here also. These 4 levels it will cover. So from this section, again, 0.8 is the maximum one. So 0.8 will be marked. And then from this section, again, 0.6 is maximum. So 0.6 will be added. So accordingly, all your numbers are processed within the CNN network. This is how it works behind the mathematical things that work behind your CNN network. So here right now, one by one, those filters I'm setting up, like what size of kernel or that windowing function will be working behind to reduce my larger matrix to a smaller version. And after updating max pooling layer, again, we can add one more level of convolution 2D layer. It is our choice how in-depth network we want to create. Sometimes we add like hundreds of different convolution layers in between to set up our model. Currently, I'll not be creating a very in-depth model, but I'll be setting up just 2-3 layers of these convolution and max pooling, and then I'll be updating the final layers of the model. It will not be like a very in-depth model because we are generating just some basic synthetic data set only just for the learning purpose. And later on, you can increase these convolution layer as per your requirement to a larger size. So one more time, max pooling 2D I'm passing here. And inside this, again, a filter size of 2 × 2 I'm passing. Most preferred filter size for pooling layer is 2 × 2. You can decide about how you want to change regions of your matrices. Accordingly, these kernel sizes or these filter sizes, you can update. That completely depends on what type of processes you are doing on your data. After this, I'm passing a flatten layer. No other parameter into the flatten layer I'm passing. This is just the basic parameter only. We are using default versions only. And this flatten layer basically helps you to convert your multidimensional data, such as the output of CNN, into a one-dimensional vector. That is easier for the final decision making on the CNN. So flatten layer just to convert your multidimensional data into a single dimension vector. And then I'll be updating a dense layer here with 128 neurons. And here also at level 1, the activation function, I'm using ReLU itself. And then I'll be putting a dropout layer. Dropout layer yesterday also I have used, if you remember, I suppose, a dropout of 30% I have used yesterday. And I have explained you there also that this dropout layer assists you with the regularization of your model. This simply prevents the overfitting of your model by setting a fraction of neurons 0 during the training process. And that setting for 0 or for cutting off the connections between network is done randomly. So randomly, any 50% of neurons will be set it up to 0, or the connections will be broken for them, so that a robust training can be done for the model. And after dropout, I'll be putting the final dense layer, and the number of neurons in final dense layer is always equal to number of classes. So in our case, the number of classes are 3. So accordingly, that will be passed. And on the output side, the most preferred activation function is softmax all the time. Whenever you build CNN model, you will observe in literature also, it is always recommended that final layer activation function is always softmax, and input and intermediate layer activation function is ReLU preferably. That gives you the best outcome generally. However, With time, researchers have deployed some new models also, and you can see them in several literature, in published articles also. So accordingly, you can experiment with other versions also. And now I'm just setting up the compile option for this model. The optimizer type I'm using is ADAM. This is one of the default optimizer only I'm using. Then loss function I'm using is categorical cross entropy, because again I have multi-class problem here, so categorical cross entropy is the best option. If you are solving binary classification problem, then you can use binary cross entropy in that case. So depending upon the problem we are solving, we can set up these parameters. So these are the model compilation entries, and then I can return the model from this function also. So this time also I'm building a function. Again, I'm not setting up the model right now. I'm just building a function that I'll be calling later on to set up my model. So this looks fine. I'll be setting it up. I got the green tick, and I'll be sharing this code with all of you here. The next element I'm inserting here is function to train model. Function to train model. So this will be almost same what we have done in yesterday's session also. Just the difference is I'm using it in the form of a function. So function to train model I'm setting up. It requires few essential elements, that is model, xtrain, then ytrain, then xtest, then ytest, these 4 elements. Epochs I'm defining are 10, for example, and batch size I'm using, for example, is 32. You can use batch size of 16 also, that is your choice. I'm using batch size of 32 right now. History will be saving for the model fitting sequence so that we can use that for further plotting, etc. if required. And here I'll be using the training process for the model fit. Next element I'm passing here is validation underscore data. And inside this, as I have not created any specific validation data right now, so I'll be using only my test data set for this purpose. Next element I'll be creating is epochs is equal to epochs, whatever we have passed in the beginning. So we have created here 10 epochs, so they will be taken automatically by the system. And then batch size is equal to batch size. The parameters only I'm putting as it is, because these values I have already defined here. So exactly same values it will be taking. And after this, I'll be just returning model history. So this is from model training sequence, we'll be getting this sequence only. So I'll just run this part and I'll be sharing it right here. Model training sequence also have set it up. Now I'll be using function to evaluate model. One more function to evaluate model I'll be setting up here. And here I'll be putting up evaluate underscore model. Inside this, I'll pass model comma x underscore test, then y underscore test, then light colors. This matrix we have already created in the beginning, so they are only that only sequence I'm using here. So test loss, test accuracy, 2 parameters I'll need in return while doing model evaluation. So we are just evaluating this model, x test, y test, and verbose equal to 0 I'm making. If you want to see the output of model evaluation, then you can make verbose equal to 1. Otherwise, if you don't want to see the output, you can keep verbose equal to 0 in that case. This is just the setting for how you want to see the display of your evaluation process. So test accuracy, I'll be updating here as test accuracy, and that up to 2 decimal points I'll be showing up here. Otherwise, it may sometimes create it up to larger number of decimal places, but I'm just limiting it to 2 decimal places only. Then I'm operating here predict and visualize a few samples so that it can make predictions over few samples of traffic light signals that we have tried creating. And predictions, it will make model dot predict. Inside this AICTE test I'll be passing, and first 5 samples out of AICTE test dataset I'll be taking. For I in range of 5, I'll use I am show X underscore test I inside. That will be just to display that sample image, whatever it is taking from the test data set. I'll just display that by using I am show function. Then the title of that image with reference to what has been predicted by the model, that I'll be printing here. So I'll be writing here predicted. The light color that it is going to predict, I'll be writing here argmax. Inside this, the predictions I'll be adding with level I. So what we are doing here, because we have used one hot encoding initially for the model, if you remember, one hot encoding we have used. So with the help of this np.argmax, I'll be again getting it back into its original form so that the predicted value I can get in the form of the exact variable red, yellow, or green. Otherwise, it will be displaying those numbers, number combination like 001, 100. That we don't need. So that is why I'm just making argmax from the predictions that the model is giving us, so that exact color information we can see on the screen. X is I'm turning off because that is not required for displaying traffic light signals. And ultimately, I'll just have to show the plot that I'll be creating from the system here. Then I'll just run this part also. I'll be sharing this set of function as well. And now I'll be setting up the final code to run all these functions in sequence. So that will help us to see the entire demonstration of all the elements that we are creating at level 1. And what I'll do here is main code to run all functions in sequence I'll be updating here. So step by step, what I'll do is I'm creating a class sequence first here. I'm naming it as main element. Then first is to generate synthetic dataset. That was my first function that I have created initially. So that function I'll be calling in the first level, and this will be returning me different elements, images, labels, and light colors. It depends on what we have returned while creating that function. This was to generate dataset, and we were returning 3 things from this function, if you remember. This was your generate traffic light dataset function. And after this, we were returning 3 elements. So those 3 elements only I'm packing up here, so that whenever I pass this generate traffic light dataset function, inside this num samples, as I told you that initially we were marking here 300. The value that we have given by default is 300. If right now I do not pass any value while calling this function, like if I put it num samples only, it will be taking 300 value from the default execution. Otherwise, I can pass value like any number, maybe 1000, then it will be creating 1000 samples for me. So you can increase these samples also later on. Currently, I'm creating just 1000 samples of synthetic dataset images here. Then in the next step, we had pre-processed dataset function. So the same I'm deploying here. And if you remember, from this pre-processed dataset function, this was your generate synthetic dataset. Then we had pre-process. It was returning these 4 elements. So these 4 elements only I'll be returning here also while deploying it, and equal to pre-process underscore dataset, exactly same name of the function I'll have to pass. And as you remember from here, In the pre-process function, we had to pass these three things: images, labels, and number of classes. So right now, if you see here, I have obtained images and labels from the previous set. So these same I'll be passing here. And number of classes, we already know they are 3. So the same value I'm keeping here. So these two elements will be provided by the previous functions. That is why we are putting them in sequence. Whatever values it has to take from the previous function, it will be calling it from there, and then it will be deploying it in its own sequence. In the next step, we'll use build CNN model. That was our next function. So it will be model equal to build underscore model. Inside this, we will pass first is input shape. That is equal to x underscore train dot shape 1, the first element, and then number of classes is equal to 3. So the shape element right now we are taking directly from the X train images. So it will automatically evaluate the training data set, calculate its shape, and that shape it will pass as input shape to our CNN model. Otherwise, when we have data set from the real world environment, if you remember yesterday, we have passed input shape based on that. We were using a pre-trained model, EfficientNet B0 yesterday. So that requires a specific image size of 224 into 224. So we were shaping all the images into that pattern only yesterday. But today we are setting up CNN from the scratch. So we are free to set up its input image size. So here I'm taking that input image size directly from the training data set itself, so that only it can update accordingly. Then I'll be putting here train model function, one more function that we have created. So I'll write here train underscore model. Inside this, I'll pass model dot x train, y train, x test, y test, and then epochs. If you want 10 epochs, you can pass that. If you want to change these values, that also you can do. By default, also we have set it up 10 epochs. If those are fine, you can keep it as it is. Otherwise, maybe 5, 15, 20, 100, any value you can give here. That is your choice. Then we are just evaluating and visualizing predictions. And for that, the last function that we have created is evaluate model function. Inside this, we will pass the created model, then X test data, Y test data, and the light colors, because it has to check the 3 colors that it was expecting. So this is your evaluate model function, and these are the 3-4 parameters that it was requiring. The same things we have passed from here. And all these elements we are getting step by step from the previous elements. The model we are getting from here, X test, Y test we are getting from here. So those values only we are updating right here. Light colors we have defined right in the beginning, so that it will be taking from there itself. That is within your this first synthetic data set. So once I have created all these functions in a specific sequence, now if I run it, if all those functions were created right, it should start our model training, and then it should help us to visualize outputs. But if we have any errors in the previous functions, then it will point out to those errors first. So let us see if it is working fine or not. Accordingly, I'll be sharing it. So I'll just click on this, and yeah, it started the training process. So everything is fine. All of you can start with it. I'll be sharing it right here. And this is working because we are creating a very basic model, so it will not take much time. It will quickly do the training process up to 10 epochs, and you will get generally a very high accuracy because just a very basic model we are creating here. This is not like a very complicated model, only just color circles we have passed. So generally the accuracy will be very high. On the other side, if you create synthetic data set for some complicated problem, in that case, the accuracy may be varying even with the synthetic data set also. So let us see. We will just observe every outcome here. You can see and the accuracy currently is approaching to 100% itself. 8th epoch is working right now, and It will then display the colors that it has predicted with reference to the image, the synthetic image that it is using right now. And once it is trained, then I'll be using this trained model on some real-time images on traffic lights. And we will see whether a model trained on synthetic data is able to predict the real images also or not. So that visualization we will do. You can observe here, once the training is finished, you can see it is predicting green and the color is also green, we can see. The prediction is red and the color is also red. Similarly, prediction is yellow, the color is also yellow. Just some random images it has predicted. And we can see all of them are predicted right. That is why it is showing us 100% accuracy. First, let me know if you are done up to this. Then I'll be using it on some real images also. Let me know in the chat box if we are good up to this level. I have shared this function code also in the chat box. You can run it. Okay, great. So now I'll be setting up further the final level, that is to test real image on trained model. And for this, I have captured some real images right here. For instance, I'll be updating this one. I have taken just from the internet some random images of 3 different colors. This is the real image for green traffic light signal. Similarly, I have taken for red signal also. And then I have taken it for the yellow signal as well. So we will just try to see if the model is able to predict these 3 right or not. So first I'll be sharing these 3 images with all of you so that you can also test them side by side on your working model. So I'll just use file bin for this quickly. Or otherwise, you can just download some images from the internet and you can try checking on them. Make sure that for the yellow light, you use yellow tint color because sometimes we have amber color also, and we have trained our model for the yellow color right now, not for the amber. Otherwise, the combination for amber will be different. So make sure just for the yellow light, you get the yellow tint itself. Otherwise, remaining 2 will be red or green also itself. So you can use these 3 images. I'm sharing this data set of 3 images with all of you in file bin. You can download these files from here, and then we'll be able to use them in the real image. So getting back here, in the meanwhile, I'll setting up here the function to pre-process real images. I'll write here define pre-process real images first, because your real images currently may require a little bit of pre-processing since they are in their original version. As I have shown you already, they contain all the background details also from the real settings. So we may need to pre-process them slightly. So what I'll do here is, first of all, load the image using OpenCV first of all. And for that, image is equal to cv2.imread, and image path I'll be passing here. Then image is equal to cv2.cvt color I'll use here, and image comma cv2.color underscore bgr to RGB. It is important to mention one thing here, that OpenCV by default works on BGR format. The OpenCV default color format is BGR instead of RGB. So when we are using some real-time image, we just have to convert it into the required format so that it can be processed easily into the system. BGR to RGB, we have to convert it manually. Otherwise, CVT will consider all the colors in the opposite manner with the BGR combinations. So this conversion is essential over here. Similarly, here I'm passing is image resized is equal to cv2 dot the resize I'm passing here, image dot 64 comma 64, because the model we have trained using this size. If you remember from the initial settings, the metric size initially I have created was 64 cross 64. So I need to resize my real images also into the same size, depending upon how the model was trained initially. So this step will help you to resize images to 64 cross 64 pixels as required by your trained model. In the next step, we will do normalization also between 0 to 1, as we have trained our model on the normalized images. So that is required for the real images also. We'll write here image normalized is equal to img dot resized dot as type. Inside this, float 32 is the pattern we need, and divided by 255.0. This is the same normalization that we have done earlier, same normalization pattern I have used here. Then add batch dimension. This is required for processing your real images, and the batch dimension generally is a standard dimension that we may need here, 164 64 cross 3. Reason for choosing 1 here, because I'm not using the very large sample scale here. I'm just using one image in the batch, just a single image in the batch. So 1 only. 64 cross 64 is your metric size that we are already using. 3 represents your 3 channels. So accordingly, I'll be passing the information here, that is your image preprocessed is equal to np.expand dimensions, and that will be image underscore normalized axis is equal to 0. So this will automatically take your normalized image, and it already knows that the normalized image has 64 cross 64 combination, and based on this it will automatically expand dimensions. The expand dimension automatically takes this entire sequence for your normalized images. So that we have updated here. And after this, the last element I'll write is return image preprocessed, and second thing, image resized. 2 things we need to return from this preprocess function. This preprocess function will return 2 things, resized and preprocessed images. Then we will do the testing, and for that I'll be setting up here one more function, test underscore real image. I'm putting them both into the single sequence. I'll be running them from here directly. Then image path, first of all, we may need, and then light colors we may need, because 3 colors we already know. On the same pattern, we'll be updating it. So light colors, it will be taking from the above sequence that we have already loaded. Then I'll be just using preprocess the image, and the function for that we have already created, and that returns preprocessed image along with resized image we know. So I'll be just calling this recently created function, this one. And inside this, I have to pass my image path. So this one I'll be passing here, and image path I'll be setting up manually further after getting my images on the platform. Then predict the traffic light signal. So it will make the prediction is equal to model dot predict, because we have already set it up the model. Now I'm just using the predict function over it, and it will use the pre-processed image for making prediction. And then we are getting the predicted label, that is equal to np.argmax. Inside this, we will pass the prediction. Again, as we know that it by default does the one-hot encoding, so we have to get the actual value out of that by using argmax. So it will just convert that probability setting into your final return value, that is your specific color. And then I am show. Inside this, I'll show the resized image for the display purpose. this will show the resized image. And then I'll be plotting the title for this. That will be based on the predictions made by the model. So I'm writing here, predicted traffic light. That is the light colors predicted label. We will just set it up based on the light colors that we have initially present in our declaration sequences. Then plot axis is equal to plot axis we can make off because they may not be required again, hide axis, and we can show the plot here. So these are the essential functions that we may need for testing our images or the real images with the created model. Just 2 functions I have deployed here. I have created, now I'll be deploying them. So here I'll write example uses. And for this image path, first of all, that is the essential variable we may need. And then based on this, we may need to test real image. And inside this, I'll pass model, image path, and light colors. So this only deployment we need, just a image path only have to pass here. So image path, first of all, I'll not be able to get it from my system directly because we are working on Google Colab right now. So first I need to upload my images on this Google Colab platform. So how I can do that? All of you can do the same. You can just go to this file section over here. Observe this, click on this file section. And here you have the upload button, this one. Just click on this upload button and then choose your these individual images. If you have zip file downloaded from the file bin, extract those elements from the zip file, get your individual images, then select those 3 images and open them up here. Click OK for any kind of warning on your screen. And these 3 images should be ready on your system here. These 3 you can see. Once you get them here, now you can find their path also. Like for instance, in the first sequence, I just want to predict this green traffic light. So I'll just copy this. I'll copy this path and I'll put it here. This is my path for the first image. Now let us see how our model is predicting it. So for instance, I'll just run this. Let me check. We may have a typo over here. Resized. It is not able to find. This one parameter I have updated here. This is with reference to the resize function. 64 cross 64 I have passed. CV2 is fine. So image resized here. Okay, this one is wrong. Underscore resized we have to pass. Now you can see it is not predicting right. Let me just correct it once again. I'll just retrain this model. Maybe some variables are lost. Let me check once again. I have tested it earlier with different set of images. It was working fine at that time. But let me check once again if it is able to predict right or not. Okay, this looks fine. I'll just rerun this one. Okay, the red one, it is predicting right. This is for the red color. I'll check it for the yellow one also. Let me see. It is making a little bit of mistakes for 2 different colors. For the green is also now it is predicting right for the green also. Let me check again for the red. Yes, red and green, it is predicting fine. For the yellow color, slightly tint it is finding possibly here. Let me find some other yellow traffic lights. I'll get some images from here, maybe any yellow color. This one I can try possibly. So I'll upload this image also right here. The path of this image I'll update here. Let me just check if it predicts well. Okay, with green color, with yellow color, it is showing some problems. Otherwise, with the remaining colors, it is fine, working fine. Let me try some other tints also if possible. This one is also a fine yellow, because currently we are working on the synthetic data set. So sometimes it is not so much accurate. For few colors, it is already giving us the accurate outcome. But for few of these, we have a difference. This is also a JPG file, so I hope this should work. This one it is finding right. You can see this yellow color, it is able to find right. And now I can check it back on other colors like red or green also. Let us see if the performance is stable. This red one is also working fine. And this green one is also working. This green is also fine. So actually we are working on synthetic dataset right now. So the straight color combinations only we have used, like 255 combination directly we have used. So if a slight difference in tint it finds, that it will be not able to identify accurately. When I passed a perfect yellow tint into this was able to identify. That is generally one of the drawbacks you will find when you are working on synthetic datasets, because there you are using a very precise combination. But in real life, actually, the exact yellow you will rarely find. There is a shade of amber in it. It will be slightly with a mixed tint generally on the traffic light. So when I'm using it with real images, that difference we are able to see in that. But still, you can test it with different image combinations that you can find online itself, and from there you can run it easily. So I can just share first of all this code with all of you. Just try to run it. You can just use, okay, yes, the entire code I have shared here. You can also take it from desktop. Definitely you can do that. For that you need Google upload functions. There are upload functions readily available. Currently in my case I'm doing manual upload, but there are also upload functions by default available. They will allow you to pick your data from any of your folders depending upon how you have mentioned that in the upload path, and then you will be able to update it accordingly. And other than this, it is even possible to set up the APIs directly. In Python, you have a lot of freedoms. Like sometimes you can set up maybe a default API by using Gradio app. A Gradio app setup also requires a code in Python. And once that Gradio API is ready, you can post a complete traffic light prediction system on the API itself. And there, whenever someone puts a picture, that it will be indicating immediately as which color it is identifying from that picture. So there are unlimited possibilities when you are working on Python platform. It just is about how well you know the functions, how well you set up your subroutines, and how well they are aligned with your coding sequence. And based on that, everything will work fine. There are unlimited possibilities when you are working on it. So currently, since I have worked on a synthetic data set, the accuracy you are currently seeing very high. But this is not always the case with the real data set. You will see very much difference in accuracy when you are working on real data set. But currently, because we had limited time in this particular session, so I was not able to use a real data set, because real data set requires several steps for pre-processing and augmentation, etc. Some of them I have shown you yesterday, but at that time we were using a pre-trained model. So there are multiple options. Sometimes you can deploy your real-time data set into your pre-trained model. Sometimes you can manually pre-process everything from your real-time data and then put it into a CNN model as per the requirement, and in-depth CNN model as per your choice you can set up. I have created a very basic CNN model, as you have seen. It just contains 2 layers of convolution 2D and 2 layers of max pooling, and then just the output layers I have passed up. But sometimes we have a very in-depth, like 5-6 layers of convolution 2D we pass, and filter after filter the extraction will be done, and then we have a very simplified sequence from the matrix. So that completely depends on your steps, what you are following, what kind of accuracies you are expecting. And in order to improve your accuracies, as I told you yesterday, it completely depends on parameter tuning. You can increase number of epochs, you can change the optimizers, you can change your pre-processing techniques. There are unlimited ways to adjust accuracies also from your system. So this is all from my side for the session right now. Let me know if we have any queries or any discussions, any feedbacks on the topic. You can post in the chat box possibly. I hope I have delivered some relevant information for all of you. I just tried following the easiest possible approach. Otherwise, later on, definitely you can experiment with some different possibilities. There are unlimited things to do with the Python coding these days.
Hello. So if participants have any questions, they can ask, madam, any questions.
Good, sir.
So if any participant have any question, you can ask some questions to our expert, madam. I think, madam, there is no question, so we can conclude the session here.
Sure. Thank you very much, sir.
Thank you, madam, for your excellent deliberation. Thank you. So we will start our next session within 5 minutes. Thank you.
Gautam sir, attendance link.
I'll give after 10 minutes. So after 10 minutes, I will post this session attendance link. Okay, madam. Hello, sir. Are you joined? Hello.
Hello. Yes,
Okay.
I am in.
Okay. Okay, sir. So our last
Yeah.
session.
Please let me know when to start.
Okay, sir. So within 1 or 2 minutes, we'll start.
Sure, sure.
So good evening, all participants. Now we start our last session. This 6 days ATAL FDP on deep learning for computer vision. So now we have our expert speaker, Sushovan Chanda. Sushovan Chanda is a scientist at the University of Göttingen, focusing on unsupervised protein segmentation from fluoroscreen microscopy and the 3D reconstruction of particle structures. His current research bridges computer vision and structural biology to uncover deeper insight into molecular organization. Prior to this role, he was a researcher at TCS Research, where he contributed to projects in human motion analysis, effective computing, and generative modeling. His notable work includes publication on emotion-guided talking, head synthesis, confidence classification from eye features, and laughter-based game control system. Leveraging his strong foundation in machine learning and image processing, Chandra's interdisciplinary research spans biomedical imaging, human-computer interaction, and understanding. So, sir will take the session now. So, please, sir, you can start your session now.
Thank you, sir. Thank you, sir, for your kind words. Good evening, everyone. It's an honor to be here. As sir mentioned, my name is Sushovan Chanda and I am from Rizoli Lab at University Medical Center, Göttingen. today I'm going to share with you how we are entering into a new era in microscopy, specifically an intelligent era where we can see protein structure using light and reconstruct them using artificial intelligence. Before going into my technical details, this is my personal journey. Sir has covered most of the things. I am just highlighting few things. My journey to this work began in India, where I completed my bachelor's in information technology and master's in computer science at Jadavpur University. And this technical background has been crucial because what we are doing now represents the perfect combination of computer science and neuroscience. Over the past years, I have been fortunate to work on multiple research projects that has led to publications and patents in this exciting field. And you can see more in my Google Scholar and LinkedIn profile. And going forward, since June 2024, I have been working as a member in the group of Dr. Ali Shaib in the lab of Professor Dr. Silvio Rizzoli at University Medical Center, Göttingen. So now, today, the areas of discussions will have these three components. So before starting, computer vision is constantly getting increased attention due to the capability of deep learning models. And with these technologies, we can utilize information encoded in images and leverage them to tackle more real-world problems never imagined to be solved by computers. So today I'll be discussing these three main areas. First, brief about expansion microscopy and specifically one microscopy. Second, 2D protein segmentation. And finally, 3D protein reconstruction. And these three components together form what we call intelligent one, I1. So let's start from expansion microscopy. So in this section, specifically, I will take you through the journey of expansion microscopy, the real world impact of one microscopy, and the introduction of our intelligent system. So the foundation of our work builds on a brilliant concept introduced by Ed Boyden at MIT, expansion microscopy or EXM. The fundamental insight was simple, yet revolutionary. Instead of building better microscope to see smaller things, why not make the small things bigger? So they have used some expanded gels and with some innovative chemistry, and they make the protein structures bigger without having cryo-EM electron microscopy. Going forward, here you can see the power of expansion microscopy. This is the work from our lab showing pre and post expansion images. What was once blurry and unresolved becomes clear and distinct after 10x expansion. We can achieve 25 nanometer resolution on conventional microscopes, something that was previously impossible. To get even better resolution, the expansion concept has been combined with other super resolution technique. Here you see expansion state microscopy by Helga Evers and EXSMLM, which is single molecule localization microscopy by Marcus Sauer. And these combinations push the boundaries even further, but they also add some complexity and cost. So researchers like Jörg Beversdorf have developed pan-EXM, showing the versatility of expansion microscope field. So instead of labeling just a few targets, he expanded the specimen and then labeled all proteins using NH-ester chemistry. With this approach, known as pan-EXMT, you can visualize the entire protein landscape in a way that resembles electron microscopy, still at a resolution which is substantially above the size of individual proteins. Their precise molecular shapes remain out of reach. Going forward, to push the limits even further, Virginie Hamel and Paul Guichard introduced the iterative ultrastructure expansion microscopy, which basically enhances expansion microscopy to achieve nanoscale level resolution. This method enables researchers to get the interesting details of protein structures like the 8-fold symmetry of nuclear pores using only conventional light microscopy. The journey then moved to even higher resolution. Last year, our group introduced one microscopy, where we combined pan labeling with optimized gels and advanced optical nanoscopy. For the first time, we could visualize individual protein molecules using only light microscopy. This represents a step toward true molecular resolution and opening possibilities that were previously reserved for techniques like X-ray crystallography and cryo-EM. Not only that, the significance of one microscopy has been recognized by the scientific community. Nature magazine included it in their 7 technologies to watch in 2024. This places it alongside other transformative technologies that are shaping the future of science. But beyond the technical achievement, what matters is real-world impact, and we know that. So in Parkinson's disease, we can take patient specimens and apply one microscopy and clearly see the toxic protein aggregates that characterize the disease. This is not just beautiful imaging, it is kind of potentially transformative for diagnostics. Not only that, even more striking, in cancer research, we have discovered something we call deadly contacts, functional synapses between neurons and small cell lung cancers. This was published in Nature few weeks ago and reveals entirely new mechanism of cancer progression that we simply couldn't see before until one microscopy is published. Now, this brings me to the core of my work, Intelligent One or I1. As we generate these massive complex datasets, we face challenges. How to analyze them efficiently? I1 is our solution, an easy-to-use AI pipeline that takes these images and generates 3D protein structures automatically. And this is the first AI-powered pipeline that takes the raw image and reconstruct them into 3-dimensional models of single proteins. What makes it remarkable is not just the power, but the accessibility. It runs in a simple user-friendly interface based on Napari, and it only requires Conda and Torch to get started. Within this environment, it provides everything a researcher needs: tools for signal enhancement, particle picking, and most importantly, the 3D structure of proteins starting from images captured on a conventional confocal microscope. Now, we are coming to the technical advancement part. So, first technical deep dive that we will proceed, that is 2D protein segmentation. This is the critical first step where we teach models to identify and outline every protein particles in our images. In this section, I will cover the state-of-the-art performance on one microscopy data, our proposed pipeline, results on both monomer and multimer data, and comparative studies with different protocol, and why we need second generation segmentation protocol. So here you can see we began by testing the best available methods. This shows an unsupervised inpainting approach with hierarchical optimization. While it works reasonably well, but you can see it misses some particles and struggles with complex regions, specifically the boundary regions or the center of the one microscopy image. Then this is another approach which uses mass cut, which basically forms patchwise affinity matrices and clustering. So again, decent results, but not sufficient for our needs, particularly when we need near perfect segmentation for 3D reconstructions. Going to the next state-of-the-art method, here we tried refining Dino's features using KNN and correspondence loss with K-means clustering. It is little bit better from previous, but still not the precision that we require. When we compare all three methods side by side on different samples, the limitations become clear. Each has strengths, but none provides the consistent, high-quality segmentation we need for reliable 3D reconstructions. So this is our pipeline. We developed this. We use a vision transformer as our encoder. This has proven exceptional at understanding global and local context in images. We convert the images into patches and process them through transformer architecture. For vision and transformer, we left the final layer and we take the embeddings of each patch. Now, this is the detailed architecture. So this is the extended pipeline. We extract features using vision transformer, formulate a graph from these features, and apply graph neural network with convolutional ARMA filters. I will come to that part later, means what is ARMA filters, and finally use a fully connected networks with softmax activation to produce our segmentation mask. The basic goal is to cut this graph into segments. A bad cut would just chop through the random connections, but a good cut, which is the normalized cut algorithm does, find the natural decision boundary in the graph. It cleverly minimizes the connection between different segments while maximizing the connections within each segment. Now, you can ask question that why it is called normalize. So older methods would just find the cheapest cut, which often resulted in isolating a single tiny segment from the rest of the image. The normalization part penalizes this. It ensures that the algorithm prefers to create segments that are reasonably sized and substantial. Not just one pixel, it queries how disconnected is the group from the whole relative to its own internal connectivity. Now coming to the ARMA part, ARMA stands for Autoregressive Moving Average. This is a classic concept of signal processing and time series analysis that we have adapted for our graph neural network. So if we break it down, so ARMA stands for Autoregressive Moving Average. So what does it mean, autoregressive? So this means the current value of a node is influenced by its own past values. In our case, the features of its neighbor nodes from a previous step in the network. It captures local short-range dependencies between nodes. And coming to the moving average part, MA, this part models the influence of random shocks or noise from the previous steps or previous layers. In our context, it helps the network be robust to noise and irrelevant variations in the image features. In microscopic data, we have a lot of variations because we have some Gaussian curve inside it. So it helps filter out the static part. And now why this ARMA we have used in graph neural network? Because by using ARMA as a convolutional filter in our graph neural network, we create a very powerful and a stable way for information to propagate through the layers. It allows each node to gather information from its local neighborhood in a way that is both memory aware, the AR part, the noise resistant, the MA part. This leads to smoother, more consistent feature representation across the graph, which is exactly what we need for clean segmentation. Now coming to the modularity and regularization loss. So first, modularity loss. So this is a loss function that directly encourages the graph structure we want. So modularity is a measure of how well the graph is divided into modules. High modularity means strong connection within groups and weak connections between groups. So by defining a modularity loss, we are literally forcing the network during training to find a segmentation where the segmentations or segments are strongly defined and well separated in the graph. So it directly aligns with the goal of normalized cut that I previously discussed. Now coming to the regularization loss, this is the reality check for our model. A network might find a segmentation that has perfect modularity but looks nothing like a protein. So regularization loss prevents this overfitting by imposing some basic constraints. Now I will move to the process visually. So we start with the input image, create an intensity threshold version, process through our VIT GNN network and generates primary and secondary mask and fuse them, and finally extract primary segments. So our boundary partitioning block is checking the segments that we got from the primary or secondary masks. Is it fully aware of the shape of the protein or not? So boundary partitioning block is responsible for coming up with primary segments and boundary segments so that we can discard the boundary segments. And going forward, we have also used Gaussian mixture models to separate better segments from odd segments. So this is a clustering algorithm. So the bottom part also shows you that our segmentation results on multimer data, and it works very well for both the cases, for monomer and multimer data. Coming to the quantitative results parts, the numbers confirm that we are means what we are seeing visually. We achieve a silhouette score of 0.67, which is very much closer to the ideal value of 1, and our Kalinowski index is over 1800. So it is also indicating strong separation between clusters. The Davis index at 1.24 shows there is still some similarity between clusters, but it is a significant improvement over existing method for our specific use case. Now we have continued to improve the pipeline. Here is our modified approach. So just 1 minute. Yes. So this is our modified approach that includes connected component analysis and physical constraint filtering. We calculate properties for each candidate particle and apply rigorous checks. The checking includes length checks, area checks, and circularity checks. This means this part ensures we only keep physically plausible protein instances and discard others. And finally, we have used for post-validation PAM module, which is partition around mediates. So we can means we have tried with k-means, but this is PAM. Basically, this is very robust compared to k-means because it is not sensitive to the squared error matrix. So finally, we are getting candidate particles. So this is a collaboration work with MIT Ed Boyden, as I primarily mentioned, who invented the expansion microscopy. Now coming to the next part, why should we stop there? The next challenge is the mixed samples. What if we have two different proteins together in the same image? And how do we separate them and identify both? This requires a fundamentally different approach, and to do this experiment, to make this experiment honest, we mixed actin and tubulin data. And the right hand side, you can see the PDB structure, protein data bank structure, which is taken using X-ray crystallography and cryo-EM. So we have used our first generation segmentation pipeline and followed by 3D reconstruction pipeline, which I will cover next part. We have got 21 angstrom, and means that is for actin data, and for tubulin dimer we have got around 19.4 angstrom. Now the question is, can we make it better? Yes, we can. So we can use probabilistic instance segmentation, and here we have used known PDB structures of actin and tubulin, and we have generated 2D projections at different orientations and uses post optimization with likelihood maps. This is finally giving us one probability score. So based on 90% similarity, we can select the segments. Based on 80% similarity, we can select some of the segments. So depending upon threshold and the probability score, we can segment two different protein data which are in monochrome image samples. And followed by, we have applied 3D reconstruction pipeline, which I cover next part, and I will show the results as well. So now coming to the 3D protein reconstruction part. So here basically the grand challenge is taking these 2D segments and reconstructing full 3D protein structures. This is where the real biological insights emerge. So in this section, I will cover the pinhole camera model, why 3D protein reconstruction is an ill-posed problem, epipolar geometry, stereo disparity, and our result on segmented particle data. So to understand the 3D reconstruction, we need to understand how we see in 3D using mathematics. The principles come from computer vision and geometry. So it begins with the pinhole camera model. A real-world point in 3D space projects through a small aperture onto a 2D image plane. Mathematically, we express this as x is equal to px, where p is the camera matrix containing both intrinsic and extrinsic parameters. So in the left hand side in figure 1, you can find pinhole camera model semantics, and here the real world point x, which has x, y, z coordinates, and y transpose is used because it is a column vector. So the real world point is projected to image plane P by a ray passing from X to the center of camera C. So now point X can be mathematically expressed by the following equation what I have mentioned. And here X is equal to Px, and what is P? P is equal to KRT. K is the intrinsic camera matrix which is mentioned here, and R and T. R is the rotation means 3D rotational matrix, and T is translation vector. And in figure 2, you can find when we have a 3D point, we have to transform it from world coordinate to camera coordinate. So for that thing, we have used the extrinsic camera parameters, which is a combination of rotational matrix and translation vector. So finally, the pinhole camera model becomes, means left hand side you can find the 2D image coordinates, and this is the mathematical formulation. The intrinsic matrix K contains optical properties like focal length and principal point. The extrinsic parameters RT describe the camera's rotation and translation in world coordinates. Together they transform the 3D world points to image coordinates. Basically, this is 2D image coordinates. Going forward, so before going into the details of it, I want to ask one thing. Now, if I show you a single photograph from Alpine range, you can understand what is in it. But could you tell me exactly how far away the mountain peak is? Probably not. That's because a single 2D image loses a crucial piece of information, that is depth. So our biological vision solved this by using two eyes, stereo vision. Our brain automatically compares the slightly different views from our left and right eyes to perceive the world in 3D. In computer vision, we do the same thing with the two cameras. This setup is our stereo camera model, and the mathematical framework that makes it work is called epipolar geometry. So let me explain how this works. Imagine you have two cameras looking at the same point in 3D space. Let's say it's a single glowing protein. So in the left camera's image, this protein appears at a specific pixel. Now, here is the key question. Where will that exact same protein appear in the right camera's image? So to answer this question without any rules, you have to search the entire right image pixel by pixel to find the match. That's like looking for a needle in a haystack. But epipolar geometry gives us a powerful tool. It tells us that for any point in the left image, its matching point on the right image is not just anywhere. It must lie along a specific straight line, which we call the epipolar line. So if you look at the figure, so C1 and C2 both are camera centers, and X is the 3D coordinate. So to maintain the stereo camera model and epipolar geometry in this case, we have to make one constraint, which is coplanarity constraint, which means the left hand side of, means the pixels of the left image should match with the right side of the means right side means right pixels of the image. So we have seen how epipolar geometry gives us a powerful constraint, but let's be honest, searching along a slanted curve line in an image is still computationally pretty expensive. What if we could make this even simpler? So that is also possible. Imagine we could take our two cameras and virtually rotate them until their image planes became perfectly parallel. This process is called stereo rectification. Think of it as digitally aligning the two images so they look like they are taken by the two cameras sitting side by side on a perfectly level rail. Once we do this, something beautiful happens mathematically. So that complex fundamental matrix that we talked about earlier simplifies down to a very specific form. So suddenly, for any point in the left image, the corresponding point in the right image is guaranteed to be found on the very same horizontal row. The search for a match goes from a 2D hunt across the entire image to a 1D scan along a single line. So this is just not a little improvement, it's a game changer for speed and efficiency for 3D reconstruction. So now, next question comes, finding depth from two images, because we are doing 3D reconstruction. So the question is, how do we actually get the depth? The answer lies in the classic concept of triangulation. So let's break it down. You have two cameras separated by a distance we call the baseline. That's like the distance between your two eyes. A nearby object like my hand will appear in very different position to your left and right eye. But a faraway object like the screen at the back of your room appears almost in the same place for both the eyes. That difference in position is what we call disparity. The math behind this is surprisingly elegant because it all comes from similar triangles. The disparity basically means the horizontal shift of a point between the left and right image, and that is inversely proportional to the depth. So the formula is very simple. Depth equals the focal length times the baseline and divided by the disparity. You can see this thing in the right side image. So coming to the multi-view 3D reconstruction. So now stereo vision is powerful, but it is fundamentally limited to two views. What if we want to reconstruct a complex 3D object from a handful of photos taken from all different angles? So this is where modern AI comes in with a revolutionary technique called neural radiance field or NRF. Instead of trying to calculate explicit surfaces, NRF does something much more profound. It teaches a small neural network to act as a virtual mathematical cloud that represents the entire scene. So you give this network a 3D coordinate inside that cloud and a viewing direction, so which is mentioned here in X and D. D is the viewing direction, and it outputs two things. First, the density, which queries is there solid matter here or just empty space, which is sigma, and second, the color that you would see from the specific viewpoint, which is C. But how do you turn this intelligent cloud into an image? That is the question. So here we use a process from computer graphics called volume rendering. So imagine shooting a ray of light from the camera through a pixel and into this virtual cloud. As the ray travels, the network tells us the color and density at every point. And we then integrate along that ray, accumulating color, but respecting the density as well. So this is the concept of neural radiance field. Now let's apply this concept to the specific challenge of 3D protein structure determination. So this table highlights why protein reconstruction is so challenging compared to conventional 3D reconstruction. We have unknown particle orientations in our 3D protein reconstruction. It has extremely high noise. It has structural heterogeneity, which is not common in normal real-world table, chair, or mountain, and missing data in Fourier space because it has lot of noise and extra artifacts inside it, which makes it an ill-posed problem, or you can say reverse problem, not a straightforward solution or problem, you can say. So what is the mathematics behind it? So we have talked about cameras and 3D reconstruction for everyday objects. But proteins, as I mentioned, are not chairs or mountains. They are intricate molecular machines. So just like nerve, if we reconstruct it with novel view synthesis, if some molecules or some artifacts comes into the 3D reconstruction, the properties of the protein will be changed. But for mountain or chair table, it will not be like that. So to reconstruct them, we can't use ordinary light. We must think about how they interact with electron beams in a microscope. So for that thing, imagine a protein as a complex, three-dimensional cloud of electric charge. This electrostatic potential is what the electron beam sees as it passes through. So now when we take a 2D microscope image, what we are capturing is essentially a shadow, a projection of this 3D cloud on a flat 2D plane. So basically the math here captures that exact process. So for a single protein particle frozen in a specific orientation described by a rotation matrix R, and possibly in a particular shape, which in neuroscience domain we call it conformational state, which is Z, the 2D image we get is the sum or the integral of the 3D electrostatic potential V along our line of sight, means perpendicular to the 2D plane. It's like you can imagine taking a complex 3D hologram and squashing it down into a 2D fingerprint. So every single one of our raw microscope images is one of these 2D fingerprints of an unknown 3D structure. So this is how electrostatic potential projection mathematically works. Now if we taking a 2D projection, our job would be much easier, but the real world is messy. So the image we capture is not a perfect shadow, it's a degraded version. So first, our protein might not be perfectly centered in the image. We model this with a translational kernel, which is T. Then our microscope is not perfect. The lenses have aberrations and the electron beam spreads out slightly. So it creates some Gaussian noise. So this creates an effect that we model with point spread function, which smears the ideal image. And finally, there is some noise. So basically, we consider it as white Gaussian noise, and that corrupts the signal which we model. So now the equation you see here is basically you can say is a recipe for the imperfect reality. We start with our perfect projection, we shift it, we blur it, and we add noise. So this is what gives us the grainy, noisy, challenging images to start working with it. Now, how we are coming to the 3D reconstruction from those 2D particles. So how do we reverse this messy process? This is where our AI gets clever basically. So instead of trying to guess the 3D structure directly, we train a neural network to become a virtual sculptor of the protein. So here is how it works. First, we define a 3D grid of points surrounding where we think the protein is. So this is our digital block of marble. You can kind of simulate like that. Then for each point in this 3D space, we ask the neural network a simple query. how much protein density is right here. So to help the network understand fine details, we first encode the 3D coordinates using a trick called positional encoding. So it's like giving the network a special pair of glasses that lets it see high frequency patterns. So basically we are also working in Fourier domain to catch this high frequency and low frequency in a pattern manner. So for each particle images we take our 3D grid, rotate it using our best guess of that particle's orientation, and then ask our neural network to predict the density at every point. So after a certain time, the network gradually learns to carve away the empty space and leave behind only the regions where the protein exists, based on some adaptive masking. I'm not going into details of those. So the most beautiful part is how we connect our AI sculptor back to our actual data. That is where we close the loop. So we take the 3D density volume that our network has created and we put it through a digital microscope that perfectly mimics our real microscope's physics. We project it to create a 2D image and apply the same blurring and shifting, which is translation kernel, and generate what the AI thinks the microscope image should look like. Now we compare this AI generated image to the actual experimental image from our microscope. If they match perfectly, then great, but initially they won't, because we have to do some training. So we calculate the difference, which is basically the loss, and use back propagation to gently guide our neural network to come up with more density points, come up with more density values to get the perfect 3D reconstruction. Now this was the background concept of it. So this is our architecture of smarter neural network. So from our unsupervised segmentation, we get the segmented images, and followed by we have some data pre-processing, which is very much necessary, because we have, if you can remember, here we have the point spread function, which is p, but in real life we don't do any integral part of it to make the neural network with less time complexity. So for that we have to apply some deconvolution in data pre-processing, and it has some data enrichment, data cleaning, and finally data integration. And this is the whole neural architecture. So I will not go into the details of it because it is unpublished work. Just I will follow the structures one after another. So we have our segmented images. Followed by that, we are doing some Fourier domain analysis. Means we have spatial domain in segmented particle images, and then we are converting into Fourier domain to get some high frequency and low frequency details. And for that, we are also using positional encoding. And then we have our encoder, and from encoder, we are getting Z conformational state, S scaling factor, R rotational matrix, and T translation vector. And here the decoder is the physics informed decoder. So based upon the conformation state, conformation shape, it will predict the more cleaner, you can say, or less noisy Fourier domain images, and we perform some affine transformation on top of it, and we get the final output images. And we compare this with symmetry loss, and finally we convert back it to spatial domain, and one after another we place this 2D image to get the 3D molecule. So this is the smartest neural network pipeline. Now coming to the result part, before going into the result section, I will say what is the metric. This is the FSC, means Fourier shell correlation, and what does it signify? And this is the only metric that we follow to compare our 3D reconstruction with AlphaFold prediction or protein data bank data. So what is Fourier shell correlation? So basically Fourier shell correlation is a method used in structural biology to measure the similarity between two independent 3D reconstruction in Fourier domain. It is calculated by correlating Fourier coefficients within concentric shells of equal spatial frequency. So by definition, you can say FSC is the normalized cross correlation coefficient between two 3D volumes, and that is computed over spherical shells in Fourier space. It can't be performed in spatial domain. And what is the purpose of it? It provides an estimate of the resolution of a 3D reconstruction, especially in cryo-electron microscopy, and it was introduced in 1986. I'm not going into details of that. And how FSC is calculated? So we have some data set of particles. So split the data set into two halves, which has independent reconstructions. Now transform both 3D volumes into Fourier space, divide Fourier space into concentric shells based on spatial frequency high or low. For each shell, compute the correlation between Fourier coefficients of the two volumes. And finally, you have to normalize the correlation to obtain the values between -1 to 1. And to plot this FSC graph that you can see in the slide, to plot the FSC as a function of spatial frequency, the point where FSC drops below a threshold, which is here is 0.143, and this value has come from cryo-EM field, and they came up with this value with several experiments, and they have fixed this value. So when it drops below a threshold, it defines the resolution. So with I1, a conventional fluorescence microscopy can now deliver near atomic detail. In just 2-3 days of imaging, we routinely reach a resolution of 6 to 7 angstroms. And this level of detail was previously unthinkable for light microscopy. Just to put this into perspective, cryo-electron microscopy typically achieve about 2 to 3 angstrom. And with the best available data set, it can reach around 1.2 angstrom. But we are only about 2 times coarser than cryo-EM, yet it requires only a fraction of the infrastructure and about 1% of the cost. And just to let you know, this is the protein of shiftless antiviral protein. Now going forward with some another results. So in here you can see the clear progression in quality from first generation segmentation to probabilistic segmentation to our latest pipeline. So the improvement you can see here. So we have gone from 18 angstrom to 10 angstrom resolution, nearly a twofold improvement. In another example, the work with means this is the collaboration with Professor Helga Ivers. So we reconstructed the septine hexamer from one data, and the similarity to the known PDB structure is also remarkable because this is the multimer data. Previously, what I have shown to you, those are monomer data. So with the multimer data, this is demonstrating that we can reliably determine complex protein structure using our method. Coming back to that mixed protein case, this is the result of those tubulin and actin data. So this is the result with probabilistic instance segmentation via differentiable rendering. So we can now handle mixed data. Here we have both actin and tubulin in the same sample. So I1 not only reconstructs them in 3D, but correctly identifies which is what, and achieving 20 angstrom resolution for each protein classes separately. But by using 90% commonalities, we got the result around 13 to 14 angstrom. And as you see here, we can now separate actin and tubulin much more accurately, even when they appear in the same monochrome image, which is very much difficult to do. So how can I say this is improved? Because this was here 19 to 21 angstrom, and now it is around 13 to 14 angstrom. Yes, this is not yet 6 to 7 angstrom because this is the very early stage of the pipeline and I am working on it. So probably in future I can share some good results on top of it. So by saying so, in summary, I1 combines physical sample expansion with artificial intelligence to identify proteins and determine their 3D structures using conventional microscopy. This opens new possibilities for structural biology in native environments. And if we are successful, then we can get higher resolution structure only by using conventional fluorescence microscope. No need for expensive, complex, and time-consuming setup like cryo-electron microscopy. So by saying so, I would like to acknowledge my entire team, all my collaborators and colleagues who made this work possible. Thank you for your attention, and I would be happy to answer any questions. Thank you. Please feel free to ask any question, any query related to 3D reconstruction or unsupervised segmentation. I would be happy to answer those questions.
Hello.
Yes.
If a participant have any question, they can ask our expert, sir.
Sir, good evening, sir.
I can share. Yes. Yeah, good evening.
Sir, my name is Pushpa. I'm calling from Tamil Nadu, Salem, sir. You said proteins and the 3D reconstruction, right, sir?
Yes.
Sir,
Yes.
is it applicable for only microscopic level images, or we can apply it for example, plant leaf images? For that part, can we apply it, sir?
Yes, we can apply it. Means exactly. So one thing that I mentioned here. Let me go back to my slides. So probably it will help me to answer. So for any kind of leaves or any kind of monuments, any human 3D reconstruction, we have camera pose known to us. But for protein 3D reconstruction, we don't know the camera poses because microscope means it hits electron beams to the specimen and we don't know what is the camera position. We can predict camera pose, but it will not be accurate at all. And the most important thing is for protein, it has many noises and artifacts inside it. So basically it is, you can see 6, 7 angstrom, 13 angstrom, 14 angstrom. So it is hard to compare with the real world data. So for 3D protein reconstruction, this is a step to follow, or you can say protein structures which are bigger. Means generally for monomer data, those are basically within the range of 6 to 12 angstrom. But for multimer data, it gets bigger. So for multimer data, if we know the camera pose, then we can do it. But for real life, as you mentioned, the leaves or tree or whatever it is, you can use NARF and any other method. Means NARF is also very old, 2020 or 2021 it came. So after that, there are many new implementations on top of NARF. Swine nerve and many more. So you can use those things. So based on this concept, which will trigger a ray from a point and through the scene, and you can sample those scenes and you can come up with some integral part of it and get the color and density of that point. And for your use case, basically tree leaves color is very much necessary. But for my case, specifically the 3D protein structure, it has monochrome image, so I don't need any color information. So I hope I have answered your questions. If not, please ask.
Yes, sir. Sir, irrelevant to this, I'm trying to capture the 3D images of the plant leaves. Is it possible to capture, sir? Anyway,
You
because
can set up
some
LiDAR. Yes, yes. 3D images you
some
can capture. So
yes,
yes, you can complete. Yes, yes. Please complete your
sir.
question. I will answer.
Yes,
Yes.
sir. Some leaves are same at the top view, but at the bottom side they will differ. Their appearance differs and they have some different textures. Only consider
Right.
the top view, we can't predict the leaves correctly. So I'm trying to consider 3D, all 180 degree image of the leaves. Sir. You said LiDAR,
Yes.
right? Yes.
Yes.
LiDAR.
Yes. So, yes.
If there any way to capture it, any technology specifically used for that, sir. That's it.
Yes. So, are you planning to come up with a supervised solution? Then you have LiDAR or Kinect system, which will give you ground truth of depth information. Then you can use those information to get the 3D reconstruction. But
Okay, sir.
I hope it will help you. Yes. Because in my previous work, when I worked in human pose estimation, there also we have some Kinect system and sensor. So, and that means that time it gave us depth information to rely on. So for your case also, you need depth information. So I guess Kinect based system or LiDAR based or some sensor based, motion sensor based thing, you can place it to your subject, and then you can capture those 3D information, and then you can train any supervised network. And I will suggest use NERF, means modern NERF. There are many new implementation of NERF.
No. NERF, yes, sir.
Yes, NERF,
Yes.
neural radiance field.
Okay, sir. Yes. Thank you, sir. Thanks.
Most welcome. I hope there is no question right now, but you can leave your question or queries to my mail ID or LinkedIn chat. So I'll be happy to help.
Thank you, sir, for your nice deliberation.
It's my pleasure, sir. Thank you. Thank you for inviting me here. So I'm concluding the session. So thank you.
Thank you, sir. So dear participants, after we give now say 15-minute break, and after 15 minutes we start the feedback session and followed by the test, online test, and then finally the value session. Okay, thank you. And now I shared this attendance link. So good evening all participants. So we now completed the 6 days online FDP on deep learning for computer vision. So hope all of you gather the knowledge on this particular topic. So as per the schedule and the guideline of AICTE ATAL FDP, now we take some feedback from the participants verbally, and after that I share the online assessment test link through Google form, and after that we conduct one valedictory session. So kindly all participants are requested one by one to tell their feedback or their opinion about this 6 days online FDP. So please participants come forward and say something about this online FDP.
So good evening, sir.
Good evening, sir.
Sir, I am Jagdish from Aditya University, Andhra Pradesh.
Okay, sir.
So first of all, sir, I'm very thankful to the coordination committee for organizing such a wonderful FDP for all the 6 days.
Thank you, sir.
Yes, sir. Really, each and every session is a very informative session, sir.
Okay, sir.
And the kind of the experts you brought from the academia and industry is really very interesting, sir. Especially the last session, really the presentation is also very impressive and very excellent, sir. So after the presentation, I couldn't able to ask even a question also. So that kind of level you are given the presentation.
Okay, thank you, sir. Thank you, sir.
And when we are in teaching, definitely we have a gap what is going on in the industry. So through this ATAL FDP, really you are bringing the trying to reduce the gap between the industry and academia. Really, sir, it's very informative sessions. Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. Your feedback.
Yes, sir. Yes, sir.
Good evening, sir.
Good evening, madam.
It was really very informative. As a teacher, we learned so many things, and the interaction from the industry person as well as academicians, both are very useful, and it will help us to teach our students. Thank you, sir.
Thank you, madam. Thank you, madam, your feedback. So any other participants?
Good evening. Good evening, sir.
Good evening.
Myself Sanjay Gatak. I am from Sikkim Manipal Institute of Technology. So previously I was in TIT. I have that as a guest lecturer. So I am very well known about this institution. So the FDP is very standard type, because I am telling that in this FDP the youth organizer try to make a gap between the industry and academic. Okay, so different expert from industry also, and different expert from academic institution also. So it is very good, that means thinking, and it is very good type of FDP, and I hope that these types of FDP will organized in future also, and we will participate in this type of FDP also. Thank you. Thank you, sir.
Okay, okay, thank you. Thank you for your
feedback. Thank you, sir, for this wonderful FDP.
Thank you.
Myself, Dr. Anurag De from VITF University.
So please give your feedback.
So
on this particular FDP.
FDP actually is very beneficial for me, because area is a very recent trend where video-based, vision-based approaches are gaining a lot of momentum, because these days everywhere there are camera and CCTV surveillance is becoming very popular in our day-to-day lives. So a lot of tasks, a lot of real-time surveillance, and a lot of integration with AI and smart surveillance systems is a need of the hour. So this FDP really addresses those aspects. What I feel, I am also working in this area in human fall detection and smart surveillance and human detection and intelligence. So I feel that all the speakers have really contributed a lot. And one another thing from my side that now after FDP not stop, discussion should go on. Not only discussion, implement should happen. Also suggest that students can also participate in this kind of FDPs because they are the one BTech students, MTech students mainly, they are the ones who should get the most amount of motivation from these FDPs because apart from faculty, they are the one who is studying the subjects and they are they are highly motivated people. So they can implement, they can find out new solution and they can do some research. So accordingly, faculty, as faculty, we are only there to guide and it's like a wonderful ADP. And I hope that my only feedback is that please organize such FDPs and also if students are also part of this FDP, it would have been very nice and more beneficial actually. Thank you, sir.
Thank you, Anurag. So please, participants, any other participants to come forward to give some oral feedback.
Good evening, sir.
Good evening, madam.
This is Safia Sheikh from Maulana Azad Urdu University.
Yes, madam.
Sir, this I have attended many FDPs, but this one is really special because I have learned so many new things like teachable machine, pre-trained models, and all the resource persons are like from the industry, so we have learned a lot, and practical sessions also very useful for me. So I would like to attend more FDPs from your like institute, sir. So please update in the group, sir, whenever you conduct any such program. Thank you so much.
Sure, madam.
Full program. Thank you.
Sure. Thank you, madam. So please, participants, come forward to give some more feedback because we have some more time to take feedback.
Thank you, sir. I'm Virendra. It's a very nice FTP. So thank you, sir.
Thank you.
So, Gautam sir, good evening.
Good evening.
So I am Bidut Bhattacharya from Tripura Institute of Technology. So
Yes, sir.
Gautam sir always organize such wonderful FDP which help people like us. For example, I am from physics, not even from computer science department, but still whatever expertise has been shown in the FDP, I could understand, not everything, but yes, definitely I got an idea and later on I can inculcate. So thank you once again, Gautam sir, for conducting such type of FDP.
Thank you, sir. So any other participants, please give your some oral feedback. Any other participants?
Hello.
Hello.
Sir, I am audible.
Hello, sir.
Sir, I
Yes,
am
sir.
audible,
Yes, sir.
sir.
You're audible.
Yes, sir. Sir, myself,
Yes,
Shyam
sir.
Pratap
Yes, sir.
Singh.
You're audible.
Yes, sir. Myself, Shyam Pratap Singh from the Sarda University, Agra.
Okay, sir.
Okay, sir. Sir, FDP is very fruitful. It is provide the comprehensive overview of deep learning concept, and as well as, sir, there are so many demonstration on the code, so that
Yes.
that we understanding the deep learning concept in very well, and as well as learning some concept tools and applications. And sir, and the content are so relevant, and one other thing is each and every session code as well as sir all the content you provided to us, that is
Yes.
this is more, sir, helpful for us.
Yes, sir.
So thank
Also,
you
sir,
so
I
much,
share the recording session recording also.
yes, sir, yes, sir, yes, sir. So thank you so much, sir, for this beautiful FDP. Thank you once again so much, sir.
Thank you, sir.
Hello.
Hello, madam, please.
Yeah, very good evening, sir. Good evening,
madam.
everyone. I'm Dr. Bharti Kavde from Pune, Maharashtra. First of all, I would like to congratulate in terms of whatever the FDP contains, the overall presentations along with the codes and the organizing was in a such beautiful manner. No time was wasted. Everything happened on time for each session. every time it was informed early, and continuously sessions were conducted. In between also I had the interaction in terms of questions for the few sessions. Whatever material or contents codes are provided, so I am sure it will be helpful for everyone in terms of using those particular concepts implementation in academics as well as research purpose. Surely I am going to use those things and I'm going to implement, because I'm eager to work in deep learning as I have worked in ML, but yet yet I have not worked for deep learning for this research work. So overall, it was interesting, informative, and insightful. Thank you very much for the organizers as well as all the resource persons. Thank you once again.
Thank you, madam. Thank you, madam.
Hello.
You're nice. Yes, madam, please.
I am from Banaja Vasin Ratha from BCT Balasore, Odisha.
Okay, madam.
So the entire FDP was very nicely organized. Especially organizers are very flexible. And thank you so much, sir, for giving this most informative sessions, which helps to everyone. Dockers and a Kubernetes introduction was very really. Thank you, sir.
Thank you, madam.
Good evening, sir. Gautam, sir.
Good evening, sir.
I am Dr. Venkatrao, Professor in EC Department, Sanketika Vijayaparth Engineering College from Andhra Pradesh.
Okay, please.
Sir, in this FDP, this is quite different from other FDPs because each and every speaker has given different topics. Those are very useful for faculty members, faculty fraternity, as well as industry people, and organizing also good. And this is quite different because what I am saying is every more than 90% faculty, speakers have given practical oriented lectures and practical oriented. Very, very thankful, very thankful to all the speakers as well as Gautam sir, organizers and everybody. Thank you.
Thank you, sir.
Thank you, sir.
So, thank you, sir. Thank you. So, any other participants, please share your oral feedback.
Good evening, sir. This is Kumar Debarma from TTADC Polytechnic Institute, sir.
Okay, please,
Sir,
madam.
the FDP was very helpful, and organizing team has it was well organized, as well as the timings and the topics were really relevant and on recent ongoing trends. So it was very helpful, sir. Thank you so much, sir.
Thank you. Thank you. So, any other participants, please give some oral feedback. So, it will take say on more 5 or 6 minutes. After that, we will share the assessment link. Hello. Any other participant like to give oral feedback? Please come forward.
Hello, sir.
Hello, madam, please.
Hello, sir. My name is Dr. Mayura Tapkire. I am working as an associate professor in the National Institute of Engineering, Mysuru, Karnataka.
Okay.
So I am really happy with the way FDP was conducted. First of all, I would like to thank all the coordinators for maintaining all the punctuality and times and deadlines. And moreover, the FDP was it was so much useful for us, those who are dealing with deep learning, machine learning, or computer vision related subjects. Not only for CS background faculties, it was very useful for non-CS background faculties also. So we will be expecting such kind of FDPs in future also, sir. Thank you.
Thank you, madam. So any other participants, please give some oral feedback, because as per guideline, we need to take some more feedback from the participant. So any other participant like to say something? You can come forward to give some oral feedback. After that, within say 2 or 3 minutes, I will share the assessment link.
Hello.
Hello.
Dr.
Please, sir.
Doctor? Yeah.
Please, sir.
This side, Professor Dharmesh Tak
Okay.
from LDRP, Institute of Technology and Research, Gandhinagar, Gujarat.
Okay, sir. Please.
Sir, I really appreciate your patience and your well-organized FDP plan, because you really manage it very well. And all the experts from the companies and various industries are really helpful to us to provide you the major insight on computer vision and deep learning techniques. And really thankful, ATAL, as well as the entire team of your side, as well as your institute, who organize such kind of really helpful for our research work, as well as upcoming the computer vision scenario, that where we need to go, where we need to explore the scenario. Hence, really thankful each and every participation, as well as the coordinator of this FDP, sir. Really thank you, sir.
Okay. Thank you, sir. Thank you, sir. Your nice feedback. So any other participant like to tell something? So I'm now going to share the assessment link in Google chat box, and as well as WhatsApp group also. And so after half an hour, I will close the link. And at 7, not half an hour, say after 40 minutes, because 12 is 35 question, so 40 minutes. So after at 7 p.m. we will start the validity session. So thank you all. Now I am going to share the assessment link in the chat box as well as the WhatsApp link. And again, all of you kindly join at 7 p.m. We will start our validity session. Thank you all. Hello. So, dear participants, now we formally start our valedictory session. So, first I invite our head of office, sir, Sri Bidut Bhajarji, sir, to say something in this valedictory session.
Thank you, Gautam sir. So, respected participants from all over the country, I was also a participant and I actively participate in the entire session. So first of all, I would like to thank our Gautam sir, who is Associate Professor of Computer Science Department, who so beautifully and successfully organized this FDP. And I was mesmerized to see the experts who from industry, from academia, and even in case of participants also, I have seen that the entire range of participants from different institutes, from different regions of the country, they participated. Regarding FDP, the topic is very relevant and very trendy, and moreover, the depth of lectures, the depth of practical demonstrations, it will help. It will help me to for thinking a new dimension in research. Moreover, I think that most of the participants who participated in this, so they are highly benefited. I was listening to the oral feedback also, and so it is a pride to our institute that we have a faculty like Gautam sir, who has organized not only this FDP, he has organized many more FDPs in past, and he is actively associated with NITTTR Chandigarh also. So for my personal taking away from this FDP is, though I am not a person of this field, I belongs to physics, but still a new dimension has been opened from this FDP. Actually, our principal sir, Professor Bijay Kumar Upadhyay, he was supposed to be present in this valedictory session, but because of his pre-assigned assignments, pre-scheduled assignments, he was unable to present. So on behalf of him, I thank all the participants from the entire country and also the ATAL for providing us the opportunity to organize this beautiful FDP. Moreover, it is sponsored also from AICTE ATAL. So we are really thankful. And once again, before closing my remark, I would like to thank Gautam sir for organizing this FDP so efficiently in such a befitting manner and an organized way. So thank you.
Thank you, sir. Now I request our HOD, Dr. Ankur Vishwas, to say something in this valedictory session. Please, Ankur sir.
Yes. Good evening to everyone present here. So finally, we are at the conclusion of this AICTE ATAL sponsored 6 days faculty development program on deep learning for computer vision. So first of all, I would like to thank you all for attending, tuning, and making the past 6 days engaging. I want to express deep gratitude to our distinguished resource persons from NITTTR Chandigarh, Magma Consultancy, etc., for their enthusiasm, insights, and expertise. Your contribution have enriched the sessions and inspired all the participants to look at the challenges in new and innovative ways. And special appreciation also goes to the coordinator of the program, Professor Gautam Pal sir, and the organizing team and the support staff. Their planning, efforts, and attention to detail ensure that everything ran smoothly, from scheduling speakers to technical arrangements for the event. So as we conclude, I wish everyone success in your teaching and research endeavors. May you continue to strive for academic excellence and innovation with collaborative spirit. Thank you once again to everyone of you for being a part of this journey and making this faculty development program such a memorable and rewarding experience. So let us move forward with the wisdom gained, determined to shape a bright future for our institution and our students. Thank you. Thank you.
Thank you. Thank you, Ankur sir. Now I invite one of our experts, sir, Gagandip sir, to say something in this concluding program in the valedictory session. Please, sir. Gagandip sir, please say something. Sir, you are muted.
Thank you very much, Gautam ji. And
thank you, sir.
really, the sessions were wonderful, and I appreciate participants. They participated very uh, in a interactive way. They communicated, and that was the wonderful thing. And also, your institute managed this very excellently. Thank you very much, Gautam ji. Thank you.
Thank you, sir, for your feedback. So I invite any participant if voluntarily come forward to say something in this valedictory session.
Yes, Gautam sir.
Please.
It's a wonderful topics has been covered in this workshop, and I congratulate you and the ATAL and the excellent participants who gave me wonderful topics covered in this workshop. Previously, I was doing a workshop on this kind of computer vision and sentiment analysis. That was my teacher was from Flipkart and scientist and Mantra, but that was a totally different sentiment analysis. So anyway, I have learned a new era from this workshop. Thank you, sir.
Thank you. Thank you. So any other participant?
Yes. Good evening, everyone.
Good evening, madam.
The workshop was very excellent. It was even informative. In this, we have learned many new topics, which and even I would like to thank mostly Saini madam, who explained all the concepts very properly and gave the coding even. So overall, looking all the expert speakers excellent, and it was very good arranged by Gautam Pal sir. So I thank all the organizers and even the speakers for this wonderful ATAL workshop. Thank you.
Thank you, madam. So thank you all. So with this, we can conclude this 6 days FDP here. So thank you all. Now I keep this WhatsApp group active so that in near future also we can communicate among ourselves in this particular research area. So thank you all. With this, I conclude the session here.
Thank you, sir. Thank you so much.
Thank you.
Thank you.
Thank you, the session. Thank you, sir.